We're working through our. Little AV bump. Okay, it's safe. It's safe to talk again. Little AV bump. We're working out the kinks, and I want to thank Postmates. Postmates is another sponsor, and we'll be sharing with our virtual audience a code for you all to get lunch. Jaho Cafe is a local cafe. They are our caterer and a sponsor. They gave us a good deal on the breakfast pastries. They'll be bringing in lunch and keeping the coffee hot and fresh all day. Aware is also responsible for our lunch, and I was looking for Roya or Terry, some of our speakers and organizers. Some of our team is coming from Aware. That's a local tech company. Roman, help me out.
Yes, slides.
Yeah, we're still working.
Oh, okay. So we should do like the, keep going. I just want to say thank you, everybody. This is the first in-person. By the way, I'm Roman. I am the GDG mentor for the Northeast. Thank you so much for coming. This is amazing to see a lot of familiar faces. New people also, and this is the first in-person event that we've ever done ever since the pre-pandemic time. So thank you everybody for coming out. This is amazing. I see a lot of folks from Lawrence, GDG Lawrence in the house in here. I see other GDGs representing. Thank you so much everybody for being part of this event. We can't thank you enough. So yeah, as the slides come in, again, you saw Elizabeth, she was going through some of the sponsors, but again, oh, here we go.
Oh, here we go.
Yeah, like I mentioned, this is a joint effort between multiple communities. This is what actually makes us stronger. GDG Boston, Cloud Boston, GDG Cloud Boston, awesome. Boston Android, right. GDG Lawrence, we have it, GDG Lawrence. Capital Region, they are online. Thank you, Linda, if you're there. Capital Region folks, thank you so much for joining. And Manchester, New Hampshire. So as you see, there's a bunch of Google developer groups from the Northeast in collaboration doing this amazing event. So next. Here we go. So our main sponsor, as you know, Google. We are Google developer groups, and again, this is our main sponsor.
They keep us going year round.
That's right. Of course. Now let's do another round of applause for our venue sponsor. We couldn't have done it without them. Thank you so much, Kathy, Sean, all of you guys. Red Hat folks in there, please give them, a round of applause to these folks. We couldn't have done it without them. So thank you so much.
Right, Jaho is right in Chinatown on Washington, and second in the South End on Washington, and another in Back Bay at Copley Square. Great coffee, great food, great place to visit. Aware has our backs and is helping to pay for Jaho and Postmates. We're going to share with our virtual audience. We don't want to have a lot of food delivered here. We're going to have a caterer bring our lunch, but at the end of the day, we'll give you a Postmates code that's good for today.
Yeah, $25 meal voucher. Everybody's going to get it for free. So everybody's going to get a $25 voucher code at the end of the session, so you can order your food. Great. Thank you to Postmates. Yeah, that's what we were talking about.
That. Yeah. Swag, yes. Cloud Institute. Norbert?
Yeah, let me say a word about Cloud Institute. They're a new sponsor for GDG Cloud Boston. They provide training. Do you want me to go at length now, or is there?
So you want to let's keep
it
brief.
Right.
We'll say more about it later. But
right.
They're a good training outfit. And
at the end of the day, I think we have some door prizes, yes, and we'll do a little bit of a raffle, the Wheel of Names.
Yes.
If you haven't been to an in-person event before, you may not know the Wheel of Names, but you will grow to love the Wheel of Names.
So we'll do more on this later when we do
the video. When we do this swag session, sure. Okay. Yeah. Yeah, so the long sleeve T-shirts without the sponsor logos are our volunteer team. Maybe we can introduce the volunteers, the other volunteers who are here, the Red Hat people and the GDG organizers. So you got me, Robin, and Norbert, right? Maybe we'll go around. Just say hi. You know. This is one of our newest volunteers. He found me on Twitter. Hola. And Harsh is GDSC organizer, right? Tell me about yourself, Harsh.
Hey, I'm Harsh. I'm with the GDG Boston University, and I'm into the web, and happy to help here.
And Harry is a long member of our team. He's really helping out with the AV, I think.
Just make sure
Issue. And I'm glad you're here. Welcome, welcome. Joe. Joe is behind the camera. Yeah, kind of running things. For this room, there's 2 rooms. In the back. Some of you probably already know Lucas pretty well, and I'd like to introduce a couple of folks from Red Hat. The camera's over here.
We're going to play the video as well?
Yeah, can we do that next?
If possible.
We're trying to go in order.
Yep.
So this is
Dan.
Mm-hmm.
Nick. Jim's on the front desk, and you probably met Kathy coming in. So thank you guys. Welcome. We are absolutely thrilled to be here. We're thrilled to talk. If anybody wants to be interested in marketing stuff, we're all around to talk about the great things that Red Hat and Google are doing together, but more importantly, what we can do to support the developers that are the most important thing in the entire engineering universe. So.
Thank you.
Play video? No.
Hi, folks. I'm Nick. I'm local to Boston. Actually, I know Norbert. This all started with a conversation at Thanksgiving. I just visited Google in New York the week before, and I said, "Oh, well, if you're having an event, maybe we can host it." So anyway, here we are. Thank you for joining.
Thank you so much.
Thank you so much. Yeah. So should be fairly straightforward to find your way around the bathrooms. We do have a code of conduct.
Yes.
And it's not that complicated. Just be excellent to one another, please. And if you find somebody's not being 100% excellent, you find a long sleeve shirt and you tell us about it, and we'll see if we can sort it out.
Great, yeah, so we will explain what the event structure is. So next slide, please. So we have 2 tracks. So if you are more of an Android person, you love mobile development and all of that, you can join the Android track, which will be on the glass room. We will direct you. It's right down this hall. You will find it has a glass door. That's where the whole Android track will be. And if you are more into the cloud ML AI, you can join the cloud ML track, which is here in this big conference room. So all the cloud and ML AI sessions will be held in this room. So that is the setup. And here is like a rough agenda of what we have. You can also scan all over the place. You will see like a sheet that says agenda. You can scan it. It's the same page as the event, but you will have a full agenda in there. You can build your own agenda. And then you know what things are going on in which room at which times. So that way you can see the amazing speakers and talks that we have throughout the day. So you can just scan the QR code available, and you have the agenda available to you. Either track you can join. So you can take advantage of it now. You can scan the QR code. It's also plastered all over the place, so you can get the agenda. Correct. Perfect. So we have so many great talks in store for you. Next slide, please. And we're going to start just brief introduction on the speakers. When you hear your name, stand up real quick and wait for the audience. So the Android track, we have our very own Sagar with profiling Android apps. Here we go. Thank you so much. You're going to have a blast with his talk. It's amazing. Next one, Madonna with advantages of espresso test automation.
You got to test.
Make sure to join her talk. That's amazing. She came all the way from New York. Hey, you got to take advantage of that. We're going to have an amazing community Ask Me Anything panel. It's going to be composed of all your Google developer groups and other product areas, GDEs, GDGs, women tech makers, GDSCs, and you can ask us anything. So you can ask the community. This is kind of like getting in touch with the community, and you want to ask your questions. That's the right time. And last but not least, the Android track was doing Android Studio Electric Eel with Sweety. Is Sweety here?
No, Sweety is going to be virtual, and her
Perfect.
colleague Kyle will be doing it as a co-presenter.
Perfect. It's an amazing talk. Don't miss it.
Philadelphia.
Make sure to put it in your agenda, and you won't miss it. Okay, next, the whole cloud ML track. So we have something. We have Aviv back there. Firebase Cloud Functions version 2. Amazing. I love Firebase. I'm going to be in that talk for sure. Next one, Dr. Terry Riopka. Dr. Terry.
From Aware.
From Aware?
Yeah, that
Here,
sounds
okay.
a little bit like mobile. Are you sure that's supposed to be on the cloud track?
Yeah.
It's a cloud talk. Okay.
ML. Next one, Mikaeri. Is she here yet?
Don't think she's here yet.
Not
But we
yet.
have-
That's okay.
All the way from Sao Paulo, is it? Brazil?
Yeah.
We have international speakers, guys. You guys are in for a treat. This never happened before. So awesome. There you go. And we have Imre. There we go. Kubernetes people. Docker, Kubernetes. That's your guy back there. Awesome. Next
All right.
one. And yes.
Yeah. We got. I hope everybody got some banana bread. It was really good. And lunch will be coming from Jaho. We got a movie. Where's our movie?
Yeah.
Can we
We're
play the
here.
movie? Oh, okay. We're gonna connect to Nagi online.
Is he on deck?
He is
coming
in from a long distance, I think.
ready.
Yeah, he's our amazing program manager for Google Developer Programs, GDG, GDE. He's such an amazing influence in the community, and that's why we wanted to be honored with his presence virtually, so he can honor us with the keynote. So if we have him on deck, let's give him
We
a.
have the Red Hat video
Oh,
too.
well, we can play the Red Hat video while he gets ready.
We have a movie and
Joe has it. Again, thank you for bearing with us. Coming in person after so long. It's a little. We're trying to get our bearings, but yeah, I just want to say thank you. But yeah, start scanning the agenda. Start setting up your agenda. Whether you're Android cloud, you can mix it up. So start doing that, and we are gonna play the Red Hat video in 3, 2, 1, go.
not because you guys are here. I love Red Hat. I love Red Hat. And to honor the fact that you guys allowed us to use your space, that the t-shirts are red. So thank you again. So you got to thank these guys. Great. So
now, without further ado.
Yes.
Hi, can you hear me?
He has to have sound too, I'm
Yep.
just saying.
Can you hear me? Can everyone hear me? Okay. Hello? Can you hear me? Hi, okay, I can't hear anyone, so if you can hear me, just like maybe thumbs up or something. All right, you can hear me, okay, cool. Is my presentation full screen or is it sort of like minimized as well? Can you see my full screen presentation? Full screen, awesome. Okay, that's great. I do hope that people who are kind of like on the live stream or who are joining virtually can hear me, because I can't hear you, but I definitely can hear myself. I'll go ahead and depends on how much time I have, I'll just step through what I have to talk about. So first of all, thank you for hosting this event. Thank you for having me. My name is Anyedi Dobong, as Roman has kind of like introduced me, talked about being an awesome program manager. Well, we'll find out. I'd like to talk a little bit about sustainable developer communities with GDG, just as part of today's event. And while I go through this, I will, generally just want to have a chat with everyone who's attending this event, either in person or joining online. A few things I would just want to touch as kind of like, why GDG? Why do we have these groups in the first place? What's the vision behind this? Then I'll share a personal story. Some of this personal story has to do with, other people who have been part of the program, who currently, have seen some growth or opportunity from the communities that, Google or the GDG program provides. And then a little bit around my opinion, if I have enough time, I'll speak about my opinion about just, how can you step up or supercharge your tech career? And this may be everything from starting or getting into tech for the first time, or maybe if you are in tech and you're thinking of probably changing careers or picking up a new technology. I think this would be very useful. It's kind of like the letter I probably would wish I to my younger self, or kind of information I wish I knew 10, 20, 30 years ago when I started my career. I hope that doesn't really date how old I am, but yeah, I'd just like to share a little bit of that. It's going to be like nuggets of philosophy, and I do hope I get there before the end of today. So where does the GDG sit in all of the things we do? So I work on a team called Global Developer Programs, which is part of, Google Developer Relation, or Google Developers as we kind of known. And the GDG program is one of the 4 programs that I would say is crucial to our community outreach, community work, where we sort of target and talk to people in specific demographics. These could be people who are starting out with technology, looking for a job in technology, early career professionals. And we kind of have this GDG program that has been for 11, 12 years that has addressed people in local communities, creating an experience that sometimes you only find in very big cities, very big countries. Sometimes it's just only in Europe and North America. Just for context, I'm originally from Nigeria. I moved to the Bay Area about 5 months ago. And conferences like, Google I/O, Microsoft Ignite, KubeCon, PyCon, not all these conferences are available. I mean, in America and in some cities, maybe Boston, maybe New York, maybe San Francisco, these groups and these meetups are generally available, but they're not everywhere. With the GDG program spread over thousands of communities all over the world, we're able to sort of recreate small meetups and oftentimes really large conferences in cities all over the world, giving people an opportunity to learn, to connect, to join, and be part of this tech ecosystem development. But also there's the GDSC program, which has sort of evolved from the GDG, which is more focused on students running campuses. We have a GDE program. Roman is a GDE. There are a couple of other GDEs in the room there. Google developer experts are people who are just naturally and sometimes unexplainably committed to the community. They do have a very high technical ability. So they would probably be, if they wanted to be, a senior software engineer at Google or anywhere, or an engineering manager or the city of a company. The sort of technical leaders in one of the product areas, technology fields that, Google is very passionate about, or Google has expertise in. This could be Android, web, cloud, Flutter, machine learning. So they have these two things where strong community outreach, strong technical expertise, and they're always there sharing. And then we do have our umbrella program, which is the Women Tech Makers program, really focused, and it's not just about women, it's about, diversity, underrepresented groups. But then it's looking at the diversity lens and creating opportunity, providing resources for people to get into technology. So all these programs are volunteer-run programs. Oftentimes when I'm in the room or when I'm speaking, and I wish I was in the room physically with you guys, but it just, didn't happen. I'm probably the one who's being paid for doing DevRel or community work. Everybody else is a volunteer. So people give up their time, and it's all about a passion. It's about their commitment. And what they're trying to do with these various programs that address specific segments is enable you grow, learn, build, how to do something. So it's all about passion, commitment, and growth with a little bit of segmentation, so that when you're targeting your message or your narrative, we're sort of able to tailor it specifically to people in the room. And everyone's welcome. You may be just beginning, you may have a lot of expertise, and you can actually plug in. So if you've got 30 years experience in technology, if you were there when they were coding with punch cards, you may be a speaker at a GDG or a GDS event, inspiring people, letting them know what it really is like to have a job in technology, right? And if you're a student, you may be part of a GDSC, or you may step up to lead a GDSC, in which case you're a GDSC lead. So there's kind of like room for everyone. And this is something that the programs we run as global development programs try to emphasize. But ultimately, I really want to thank the organizers of the event, organizers of these groups, the organizers of these, chapters and clubs. Their passion and their commitment for their own personal growth and for the growth of all the people around them is what drives the Google developer groups and global developer programs as a team. And this is one way we try to appreciate and show the network. This is just our network of influencers, community contributors in North America. And this is not everybody. So November last year, we were able to get everyone together after how many years of, post-pandemic or pandemic life, and brought everyone to Sunnyvale. We were roughly, I think, about 300 people in the room. We had GDEs, we had women tech makers, we had GDSs, all coming from different parts of the US and Canada to share and to connect on their passion of providing these opportunities, putting together these events and meetups. And it's usually energetic. Sometimes it feels like maybe a benefit or an incentive to come, but the people who really run these communities, it's not really about, we don't pay them, even if we fly you over to the Googleplex or anywhere. Yeah, that's just a trip, right? It may be funded, it may be, fully, partially reimbursed, but it's not enough. This is just people coming here, talking about technology, connecting their passion, and actually building networks that they could use to strengthen their communities, professional growth, and create opportunities for others. So this was very energizing for me. It was the first time I got to meet some of the people that are there in the room. It was my first event in North America as a regional lead, driving the GDG and the GDE program. And I think the energy in the room is some of that. It's still that passion that drives us into this year and even this season that kind of feels a bit gloomy all across the tech ecosystem. So, but why does Google care about GDGs? This is pretty straightforward, and I'll share this deck. There's actually a link to this deck. There's a bit.ly link, so you can actually follow, and I'll drop it in the chat very soon. But it's really about, we as a technology company, we create really good products for ourselves and allow people to build products on top of those products. It's like a platform, like when you say API. And with the GDGs, we get first-hand information and connect to people who are actually learning, using, and building this on these technologies. So we really want a lot of very first-hand feedback, not marketing geek speak. We want to let you understand. We say our team drives awareness, advocacy for Google's products. And it's a partnership. We want to hear back. We want to see how these products are being used, in Middle America, in North America, in, rural communities, in big cities. What kind of apps are what do people care about? And how do these products, platforms, APIs, how do they even perform? We can't envision everything you're going to build. And then we believe in the power of developers that you can build anything, right? If you have the right tools, if they're simple, if they're straightforward, if you have the right guidance. And when we feel that one of the best ways to support you is through communities, because the people who you live around and you connect with know you and probably even know our products, how they'll be useful to you much better than we could do wherever in the world we're based. So the vision of the GDG program is just to be the most helpful and trusted resource to learn and build on Google developer tools. There's so many resources on, and many of them are amazing, whether they are third-party products or whether they're products built, by online learning schools, Udemy, Udacity, Coursera. There's lots of roadmaps out there. There's lots of stuff you can actually learn technology from. But oftentimes that connection with someone who's close to you, you could reach out to, you could ping, you could send a message, or you could walk across the room to go and meet, or you could meet at an event, is usually very valuable. And we feel that the Google developer groups and this sort of like distributed structure of local meetups and, is a way to help you learn, especially much more about Google's tools, which we know about and we discuss with the product teams, and we make that available. So you could build anything with Google, whether it's a ride-hailing app, whether it's just a game, whether it's something that uses, AI for, medicine and finance and fraud detection. There's lots of tools and products that Google has made available. And we feel that just writing documentation and tutorials is not enough. These in-person connections you get from communities could be very useful. So how are we going to do this? We need to show up for you, right? We need to be out there, be in as many cities as possible, big and small, whether it makes, sense or not. I wish I really could have flown there so that I could show you that I was showing up. I sort of wrote this deck or edited this deck with the impression that I'd be in the room with you. But we also need to get back to what we do best, which is connecting developers to each other, connecting to one another, connecting with you. And if we look at the times right now with the environment around us, 2 years of, the pandemic and a slow recovery, and there's still health concerns and health scares everywhere. We've got to do this cautiously, but we have to provide the platform and a little bit of the funding or resources so that these connections can happen. And I do hope that today with this event, we are sort of facilitating that. And we would like to get feedback on what we can do more within our resources to continuously make this happen. So the GDG community is an important partner to Google. DevFest, you would see in a couple of the slides and some of the notations, DevFest 2022. It's not like it's last year. Think of it like a sports or football season where it starts in 2022 and ends in 2023, right? So DevFest usually or sometimes is built to host in the fourth quarter of the year. So DevFest season 2022 ran officially from September 2022 up till December. But because of a lot of things, and sometimes it's even just more convenient, the weather and all that, we have these events spilling over to the next year. And that's kind of like perfect. It works for the community, it works for us. So this year, we found that our teams at Google, the cloud team, the Firebase and Flutter teams, the web teams, they actually came in and designed more content, more resources, put in a lot of funding to make sure that our GDG communities who have that firsthand through our organizers, speakers, and influencers could do more and learn more about Google and know that the teams at Google are actually creating content specifically for them to understand the way maybe Firebase and Flutter work best together, or how they could use cloud as a back end for something else. So there's a lot of stuff that goes into the feedback we get, which is why it's important to give it to us, because we're able to talk to different product areas at Google, and they're able to share content, resources, and plan to provide this information, to our communities. So let's continue to DevFest to connect with each other. DevFest is an annual decentralized tech conference. It's hosted by Google, developer groups all over the world, and they do it at their convenience. We do definitely try to influence the content by providing these resources, but ultimately people choose what they want and figure out what's best for their community and run with that. Just want to make sure I'm doing well on time. And then finally, why do we even have the GDG in the first place? So I told you I'll talk a little bit about a personal story. So there's this blog post, and once you get the slides here, you can link to it. Jennifer, who's the GDG organizer for GDG Northern Colorado, really talked about how she moved from, it's actually from teacher to developer, right? She had a life-changing community experience through the GDG, through the DevFest, through going to I/O. It's continuing to provide ongoing education for her and having a positive career impact. And that's been absolutely amazing for Jennifer. And in many ways, it sort of mirrors my personal story, right? Coming from Nigeria, average middle-class family, spent a lot of time, growing up, my father was a teacher, my mother was a teacher. But then today, against all odds, first of all, at the age at which I joined Google, which was like 7 years ago, and then I led Sub-Saharan Africa communities team for roughly about 6.5 years. And today I have the opportunity of doing this in North America with definitely a lot of imposter syndrome and, not even believing that I'm here speaking. I mean, when I joined this team, I found it very, very difficult many times just to say I'm the regional lead for the GDG and GDE program because it just didn't sound right. And we all feel this way, right? I don't know if I sound confident on this call, but definitely stage fright and there's all this kind of stuff. So connecting with this community and sort of figuring out which topic, which resource, which direction, which opportunity, which friendships can change your life and provide you the education that you need to really grow your career is one of the reasons why the GDG program exists. And I think my story is partly a testament to that. And there's many people in the room that can relate with you on this. I'm just going to take a very quick look at how we're doing on time. Any messaging, anything, I'll look at the chats very quickly. If there are any questions or backstage, I do have, I would say, just one more section where I dive a little bit more about my personal story. And I'm adapting content from stuff I think delivered about 1.5 years ago, mostly to inspire a couple of people who are either changing careers or getting into technologies like during the pandemic. And I'll run through this list
So
pretty fast.
far, no messages, Nagi, on the chat. Can you hear me?
Okay. Yeah, I can hear you. So no messages? Okay,
so
cool.
I see that in the chat, no messages. I'm checking the Q&A. And I think we are ready to start the next session. I don't know if you are ready for the next session to join us.
Cool, that's me, Anyeti, or the rest of the audience. Can I get 5 minutes?
Thank you so much, Nagi, for joining us for this great talk. And we are looking forward to see you again joining our events.
Sure.
Nagi, yeah. And I will pass it over.
All right, I guess time. If I could do 5 minutes, I would have, but that's fine. I know we're running behind schedule.
Yeah. Thank you, Andrew. Thank you so much. Give it up for him. Thank you so much. I'll get those 5 minutes next time I see you. I'll get those 5 minutes.
Right.
Yes, great. Thank you for the suggestion. Okay, so let's continue with the next one. So again, remember, the cloud talks are going to remain here. So you can stick around for Aviv's talk here. Android sessions are going to go on down the hall at the classroom.
In the classroom?
Yeah.
Sagar is going to be starting. We'll take about, 10 minutes? I think we're going to try to kick off in 12 minutes at 10:30. We're going to try to start the next session. If you need some more coffee, and if you didn't get a t-shirt, I don't know, I think we're running low on the juicy sizes, but we might have a large left for you.
Great.
Yeah.
when it comes, most of them Google Cloud, different topics, created a few open source projects. The last sentence, and I'll be happy to answer. If not, around or after that, and the time I'll hang around here. So Firebase. So a little bit of show of hands. How many people have heard about Firebase? Not surprising. How many people actually use Firebase in production? So that's a smaller number. And probably the smallest number, how many people have ever used Firebase function in production? Oh, that's a really low number. And I guess if I ask how many people have used Cloud Function version 2, maybe one person? No? Okay.
Just you.
Probably just me. No?
That's how special you are.
I'm just an early adapter. And I like to think everything. So a little bit about Firebase. So Firebase was not made by Google. It evolved from a company called Envolve in 2011 and created a new company. The first product was real-time database, which is one of the major components of Firebase till this day. Think of a real-time database like a normal database, document-based database, or whatever, but you can trigger callbacks on specific events. And that was the selling point, especially if you're going to build mobile application that you don't want to pull the database all the time for changes, or you want to connect. So you register for those callback, and then you can create your own workflow based on events that were happening on your database. So you just register. Or the classic textbook example is chat application. So you send a message, it's in the database. Now the recipient gets a notification and can pull the data. And you don't even need to be connected to each other. You can synchronize application data across multiple mobile devices, both Android and iOS. And basically, it assists people to write their own mobile application. If you remember, there also was a product called Parse later on, acquired by Facebook, and then they killed it. And there were the two major components if you wanted to build, two major play if you wanted to build your own mobile application without the need to write or to delve too much into the backend stuff. So they started with two major products, hosting and authentication, and more feature when coming up. One of the product is Firestore, which is basically, if you're familiar with AWS, it's the equivalent for DynamoDB, document store, cloud-based, managed, highly scalable. There's Cloud Function, remote configuration, which lets you do a real-time configuration of your mobile app just by setting some flag in the database. A lot more analytics and much more. I'm not going to dive into all the Firebase offering. Okay. So what are Cloud Function? So Cloud Function, if you're familiar with AWS, the best equivalent is Lambda. Basically, you've got the function, it stores in the cloud, as its name says. You can call it and get a response. Why use Cloud Function? It doesn't matter whether it's Firebase or Google Cloud Function or AWS. It's small, it's only function, it's stateless, and you don't need to manage it. Once it's up, it's managed, auto scales, etc., by your cloud provider. So that's, again, take the burden of operating a backend system. So yes, Cloud Functions are not the answer for anything, but there's a lot of use cases that you can use them. So Cloud Function in Firebase or can be called in different ways. You can call them either directly via HTTP call, so you're performing the HTTP call, etc., and the server got the regular HTTP payload, or you can call it directly from application using the SDK, and then the server will get an object that it can work on it. But basically, the functions are the same. And there's a bunch of triggers, from the real-time database triggers to remote configuration trigger, authentication, etc. One of the nice things, since you're using a framework, you can separate between the thin layer that accept the call, meaning either from the web or from the trigger, and the actual code in the function. So you can reuse what the function is doing and activate it with different payloads based on different cases. So you only have to write the function itself, get the data, and then call the actual stuff that needs. So, Cloud Functions version 2. It's now public preview. It's production ready. Not all the features are yet ready, mostly around some kinds of events, but it's there, it's running. The infrastructure is more robust. You have more control about the function runtime, about performance, stability. You can select different types of machine to use it. And it's powered by two interested subsystem or infrastructure. The first one is Cloud Run, which I'm going to touch about a little bit later on, and Innovate. So, and this is a thing that I've noticed in a few years back. Google has some serverless or application serverless options, starting with App Engine, whether the standard or not the standard. They have Cloud Function, they have Firebase Cloud Function, they have Cloud Run. But the thing that has been noticed in the last few years, there's some consolidation. In the past, each of those services uses its own mechanism or infrastructure to provide the service. But Cloud Function and Firebase Cloud Function are moving to use Cloud Run as their infrastructure. So it's going to be consolidated. I'm not from Google. I don't know the plans, but it makes a lot of sense. Same infrastructure, very stable, very reliable, and different ways to operate it. And DevFest is a framework to consume events, either custom events or predefined events by a cloud provider. So, Cloud Run. Cloud Run is a managed compute platform that automatically scales your stateless containers. And Cloud Run is serverless. It basically abstracts the infrastructure management, so you can focus on writing your application and not operating. Cloud Run is built upon an open source project called Knative. Anybody hear about Knative? Yeah.
I have a question.
Yes.
How is this different from uploading my service or function on a Google Cloud virtual machine, let's say?
If you load it on a virtual machine, you'll need to take care of the availability, scalability, and manage it by yourself.
Scalability we can take care of using...
Yeah, there are tools to do it, but still you need to define the auto-scaling group, you need to define where to scale. You can scale to zero. And one of the advantages of function that you can scale them to zero. Of course, paying the cold start cost.
The other big thing is he cannot have zero downtime, right? Cloud Run will only happen when the event happens, right?
Yes and no. So in Cloud Run and in Cloud Function, basically, if you are not using the function or your code, the function is going down and will start the next time somebody code it. But you can say, I've got a very high available application and I want to minimize the zero time and I'm willing to pay the cost. So you can say, I want to have X amount of minimum instance up in there all the time. So it's up to you. You have full control of that. But one of the things that if you don't use it, you won't pay. But while using virtual machine, you're paying them whether or not use them or not. So, and you need to manage them, and you need to back up them, et cetera, et cetera, et cetera. And you need to deploy them. So there's a lot of overhead running on virtual machine. I'm not saying that, but again, Cloud Run, as I mentioned, it's stateless. So if you need something with state, probably Cloud Run is not the best solution for you. Also, You probably can hack it. And now there's a beta feature of affinity for session, but it's still in beta. I haven't tested it yet. That might be solve some of the ability to do some stateful operation. So Knative is an open source project that runs on Kubernetes and basically lets you to build serverless function on top of Kubernetes. Google version of it, which basically it's the same code, but they took the burden of operation upon them. You've got two versions of Cloud Run. The one is the fully managed one. Basically, you give Cloud Run a container, and Google will run it on top of their infrastructure and will take care of anything. And you will be only paying for what you're using. The second option, let's say you've got some security or more concerned about privacy, and you already got a Kubernetes cluster that is up and running, you can deploy Cloud Run on your Kubernetes cluster, and basically, and the interface is the same. So if you're already using the machine, then you don't have any extra cost by operating Cloud Run on top of it. So that's up to you. The interface is the same. I wrote that those are 4 years old, 3 years old, 2 blog posts. One of them, when Cloud Run went out, I did some benchmarking and comparison about it. And the second one, hacking Cloud Run. One of the limitation of Cloud Run and also Cloud Function, the first version, that if nobody called the instance of Cloud Run on the function for 10 minutes, 15 minutes of idle time, they took it down. So you couldn't use it for long running operation. And in this post, I say how we can bypass that. Basically long polling. If you want, you can read it. Okay. Event Recipe. Event Recipe is the other mechanism that basically powers Cloud Function, and also, again, the consolidation at Google, not just with Cloud Run as the operating the infrastructure layer, but also as Event Recipe as the event.
Is Event Arc a product or it's a concept?
Actually both, but it's a concept, but it's implemented.
So like you have Firebase on Google, so there's something on the Google console, there'll be Event Arc too.
Yes, so you can create your own custom events, or you can use a lot of predefined events, and I'm going to show some code later on. So basically you've got producers, that create all kinds of events. Some of them are predefined. Here we can see Google Cloud Sources, or your own application can publish it, mostly to PubSub. Then there's a framework, and then you can be a subscriber or a consumer for those events. And that's basically allows you to do lots of things, a lot of customization without the need to take care of how do I pass the messages from one system to another. The framework will take care of it for you.
So is this like the equivalent to like the Azure Event Hub?
I'm not familiar with Azure,
or
sorry.
What this was something on AWS, right?
So it's, the power underneath is PubSub. So I guess you can build some kind of a system on top of any queuing system, either Kafka, SQS, or Azure. But it's basically Google send all those events into those systems. So all the predefined Google events. So it comes already.
Can it also store and replay? No.
No. So that's, once you consume it, it's gone.
Okay, got it.
But it's battery included, so you can use it from a lot of things from day one. So you can, events can be sourced from Google Storage, BigQuery, Firestore, and currently about 60, give or take 60 Google Cloud sources. Okay. So beside the fact that all the infrastructure is new, there are two major things that are new. The second one, it gives you better control about core setting, etc. It's nice, but I think that the first one is more important. Usually, or historically, when you activate a cloud function, it could be Google, Azure, AWS, or whatever, you call a function, the system will spin up an instance, process the data, responds to you, and that's it. If you need to handle 2 requests, 10 requests, 50 requests at the same time, the system will spin up as many instances as needed.
So one question is, the first says a function instances can now execute more than one request at a time.
Yes.
So it creates multiple instances of the function?
No. Think of it like your application, which is Dockerized.
Right.
And your application has got only one endpoint, X. But if you have a web application, any normal web application can handle multiple requests of the function at the same time. This is what's happening. Basically, Google, you created a function. Google creates a Docker image for it, and give it to Cloud Run. So, and you can define, based on your application, the concurrency level. So the default is one function without the need to spawn a new instance can handle about 80, if I remember correctly, 80 concurrent requests. This is configurable on the application, on the Cloud Run and Cloud Function setting, and also you can select the kind of machine that you're using. So if your application needs more memory, spin up a machine with more memory. If your application needs more CPU, you cannot mix and match and predefine machines, but this gives you a better control, more economics, and also this removes the needs of cold start for function. Because if the container is already up, you don't have to wait a few seconds or whatever time it needs in order to serve the next function. So those are the two, from my point of view, those are two big selling points for those functions.
Excuse me, is the cold start on the order of 2 seconds? Or?
It depends on what your application doing. If your application got a lot of initialization code, that's it. If not, it could be more, but that depends on you. And there's a way, I'm going to show you a snippet of code to how you can reduce it.
What's the limit like in AWS Lambda, right? You can have up to 10 CPUs.
I don't remember on top of my head.
And like 10 GB of space, right? So for this function, is there any limit?
Yes, but I don't remember it on top of my head.
Okay, sorry.
I think it's 8.
Okay, makes sense. Okay, so I mentioned before that I did a blog post on how to hack Cloud Run. So Cloud Run used to have 15 minutes timeout. Cloud Function had 9 minutes, different technology. But now you can, it's an hour. So it should be good enough for most applications to handle. Even if you write very poor code and slow, I guess most cases you won't need an hour to handle most of the cases. Again, this is not a magic, Cloud Function are not the magic bullet, but they can solve a lot of use cases. Another thing that makes the developer or DevOps or whoever deployed them manage your function a little bit easier is now that they default into the default compute instance service account, so a little bit easier, less steps, etc. So it works out of the box, and a lot of new triggers were introduced, and we'll touch it about. So this is like a shopping list of triggers. I'm not going to read it because I guess everyone here can read it, but there's a lot of variety and a lot of ways to call. Some of them are based on event RC, some of them are not.
So these are new, or some of them are old?
Some of them are old, some of them are new, yeah. What's not supported yet? Firestore, Firebase authentication, and Google Analytics. There are some triggers that are for Firebase authentication that are already, you can use them via event RC. Those two are not, but I guess they'll be coming. Firestore, I guess, also will be coming. The real-time database is there. So if you want to trigger your function based on events that's happening in the real-time database, you can. The ones in Firestore or not. I'll be waiting for them because they're very useful to use the Firestore event to create your own logic. I don't know if you want to delete something upon an event or do other things. But they're becoming, it's still in public preview. So I'm going to we're going to see some code today. Full disclosure, I'm not a JavaScript or TypeScript programmer. Not my language of choice, so please don't critique my code, okay? And most of the code that I'm going to display today is taken out from Google sample, etc. This one was taken from a real-life project a few months back. Some friends of mine and me, we created a service. We closed it because we didn't have a good product to market fit, but I took that option to migrate it from Cloud Function V1 to V2. And this is a simple function, basically getting the last post of a user. So in version 1, we needed to change the columns from V1 to V2, and a little bit of the function signature. And you can see that I'm getting the data not from the context, the authorization data, but from the request itself. And that's it. That's all the change. Okay. And touching back on cold start, etc. This is a trick. It worked with V1. I haven't tested it if it's really anything on V2. I didn't measure it, but this is a way to delay your loads, the function or the initialization of function only to the first time that it's called. Because in version 1, you've got an index file with all the function definition, and the system is loading it the first time. So every initialization that you have to do for function, it's done at that time. So there are a few tricks in order to delay it. One of them is if there's commonality between functions, do the initialization on global level, so you'll save some time. And if you have some function-specific initialization, don't do it when the function loads, but wait until it actually codes. So wait until the real function is actually called. And this is just a wrapper around the real world. Never tested it with V2 if it has an effect or no, but the code is there, so I'll show it. So you can see moving from V1 to V2 is basically almost no brainer. You probably can write some script that will do it for you. So as I mentioned before, you can call the function directly, either from your app, via the SDK, call it via HTTP request, use Cloud Task to enqueue function. So you can create a task in Cloud Task, which is, again, a fully managed service by Google, and the function will pick it up and do it, or using a Cloud Scheduler to run it on Scheduler by supplying, you create the schedule. The syntax is like regular cron with all that stuff. And when it's time to, and you supply it with an endpoint, and when the function, when the timer expires, then your function will be called. Okay, let's go back a little bit for triggers. So as I mentioned before, a lot of ways to trigger those functions. Okay. Anyone here heard about Firebase extensions? No. Okay. This is I don't know why, and not related to Firebase functions. I don't know why not a lot of people are aware of this, of the Firebase extension, because that can make your life easier and save you a lot of time while developing application. Basically, there are prepackaged solution that hooks like that into your Firebase project and can save you a lot of time coding and managing, etc. So you install them. There's a nice marketplace and the UI, and they can perform tasks responding to HTTPS requests, schedule event, or trigger from other Firebase or Google product. I use them in the project that I mentioned before, that actually makes my life easier. So what kind of extension do we have? We have extension that you can stream your collections to BigQuery. So you can say, That collection, I want to, for example, users. I want to send all of my user extension to BigQuery, and then it all run some analytics on top of it. You can resize images. Some of the extensions basically are done by Google and some by third party. You can delete user data upon an event, trigger email by SandGrid, using Stripe, Twilio, and many more. Also, you can have multiple instances of the same extension, each one configured in a different way. So you can have multiple instances of streaming collection to BigQuery for each collection that you have. Whatever. It's very, very helpful. So there is an extension by Google. It's that basically when you upload a file to a specific GTS bucket, that the extension automatically find out whether or not it's an image. Then you can define, like, resize it, name it, do some manipulation, etc. It's nice. But let's see what we can do after the extension is run. So the mechanism that you see here is basically upon event RC. This is the name of the event. The convention is a Firebase extension. The name of the extension, the version, and the complete is basically you get the event once the resize is done, and then you get all the data out of the event payload. And in this case, we are writing it into Firestorm. But you got everything for free, and you can do whatever you want. This is a demo code by Google, not real production code, but I think it's demonstrate the point. Okay. Another interesting thing is authentication. As I mentioned before, not all the events on authentication are yet ready to production, but there's two events that you can use. You can basically use some authentication trigger. There are two different triggers before a user is created. So a new user is created and saved to Firebase authentication. And before the token is returned to the user saying, okay, you're good to go, you can do some logic. You can say, okay, if that user comes from that address, I don't want or whatever you want. And the other one is a little later in the process before he's signing. So two different tokens. And again, the code. You register to the event, get the data, and do whatever you want. Again, very simple, very easy. And I think going through the code, you see there's a lot of commonality about the way that Firebase Cloud Functions and Event RC are handling events. You know, once you write your first function, the rest of them, at least in terms of boilerplate code, etc., it goes like that. You can focus really on the stuff that you know how to do, your application, your competitive advantage.
Question, Aviv. So are you saying like that this piece of code, like this 6 lines of code, whatever, is all you need to deploy a service and run in the cloud?
No, this is the code that needs to get the function. Deploying it, it's like Firebase function deploy, whatever.
Sure. But that's it, right? Then a server's running in the cloud, runs thousands of instances, just 4 lines of code.
Yeah. Of course, you can add, as you're sitting in the first example, you can select how many servers you want to operate. But again, it's annotation, etc. But plain and simple, just it.
Like AWS Lambda, right? You say the maximum concurrency is too much. But if your function is not called, that server will still keep going on? There's no timeout happen?
Google will take it down after timeout, etc.
Let's just give an example. Suppose I have a timeout of 1 minute.
Mm-hmm.
Okay, and in an hour I got 10 responses. Sorry, 10 requests. Okay, at like minute 1, minute 10, minute 15, and whatever. 10 responses, so timeout. So will I get charged for like 60 minutes or
No.
for 10 minutes?
No, if you will charge, the model is charged about CPU utilization.
Right, CPU an hour.
Yeah. No, that's really the level we want to take down. So it's very interesting to take the function down if it's not operating.
If you're using a personal account, what?
Yeah, but personal account, I think Google are pretty much generous with how many functions you can use. I'm going to consulting for some company, and basically all the development is almost free on top of Google. Yeah, there's a feature that they think it's very generous, especially if a 1 or 2 or 3 person shop starting your application. And again, if you're working on VM, it will take out of your credits. If you're working with stateless, with Cloud Function, or with Cloud Run, then you've got a better utilization of your credits, let's put this Okay, so in theory, I would expect that function version 2 will be faster, I think, more performance than version 1. Because you can run them in parallel, the infrastructure is new, etc. But again, we engineers, we like to measure things and not just assume. So I took some code from one of the Google examples and wrote it in. It's the same function. Basically, the code is doing the same. One of them is version 1, the other one is version 2. It just takes a date, format it as a string, and return it to the user. So no database operation, nothing, just a little bit of CPU, and that's it. And I put it to the test. So about test configuration, I use a tool called K6. You can run it on your machine. You can have a Docker image. You can run it. There's some free tier for the cloud service, so you can just run it on the cloud, and that's what I used. It's written in Go. It's very nice. I used it before, and the test was very simple. 20 virtual units, as they call it, running for 6 minutes, 30 seconds of ramp up, 30 seconds of ramp down, and in between, just calling. So one thing to notice, it's not related to performance or anything, is the URL. And if you're familiar with the convention, you can see that version 1, that's the region, that's project name, cloud function, and the name of the function. Version 2, if anyone here used Cloud Run in the past, this is the URL that correlates to Cloud Run conventions. So you can tell a little bit about where the function is running by understanding the URL. So you can see that the number of functions was a little bit higher on version 2. But if you go into the details, you can see that minimum time was 10% faster on version 2. Average was 10% faster. Median 10%. Standard deviation was almost half. P95 was way better on version 2, and max time was 4 times faster on version 2. So version 2 is faster, not by much, but 10 max time to respond to a call. So the longest that probably behind it, it's a cold start, but not necessarily. So you can see that cloud functions are faster by 10%, which is nice, but they're more evenly distributed. So you know what max is 4 times. Yeah, 4 times. And the standard deviation is almost half. So it's more reliable, you know what to expect. And you know, like predictability.
So this was the same code which apart from the APIs.
The same code, just one was brought to version 1 and deployed to version 1, the other one to version 2. So nothing fancy. I think it's plain and simple. I try to eliminate any noise from this test. And that's why the function is hardly doing anything. It's simple. I guess if I would run it longer with more concurrent requests, we would see some difference because the fact that each instance of can be, you can specify concurrency levels. So if you can specify a higher concurrency level, you eliminated more and more cold starts. If you're running a higher workload, then the difference will be much higher. Again, even with that simple measurements. You can see that if you're looking for performance and reliability and predictability, you should go to version 2. Yeah, everything was called same data center, same data center, same region, and they were called from the same cloud. Okay, so I tried to eliminate networking, as much noise as I can. I didn't test it from my computer. Okay, so also I tried to minimize that. And I ran it a few times, and it was consistent. So a little bit how I'm doing the time. Okay, so I'm trying to talk faster. So I won't read it, but as I mentioned before, there's Firebase Cloud Function, and there's our Cloud Function. And I think a couple of weeks ago, Google announced, again, public preview for Cloud Function version 2. Request time is go up to 60 minutes, the same as Firebase. You can select larger instance type, more concurrency, up to 10,000 concurrent user. Again, you can predefine the number of minimum instance, traffic splitting, which you don't have in Firebase Cloud Function. And it's nice because
how much like in AWS Lambda you can have 10 GB of temporary storage?
I'm not familiar. I don't know. But again, Cloud Function, you probably don't want to use storage, local storage, because you don't have access to it. So if you need some storage, you use it in there.
So like for example, you're doing that image, right?
The image is not done there. The image is done by an extension that works on top of Google Cloud Storage.
Oh.
Okay. One feature that is very good, traffic splitting. So you want to release a new version of traffic and want to make sure that it's working. Release it to 10%, monitor that. That's good enough. Move it to 100%. The way to do it actually in Firebase is a bit different. In Firebase, you can deploy to preview channel, but you cannot deploy a function to preview channel. So there's some advantages of cloud. And again, the power and technology behind it, it's Cloud Run. Probably in the next couple of weeks, I'm going to try to do some measurement to see if there's any performance improvements while moving to Cloud Function version 2. Okay. That's basically Cloud Function. You can see that it's almost the same as Firebase Cloud Function. Instead of calling Firebase, importing from Firebase, you import it from Google Cloud, and then you register to an event and do your thing. This is one of the things that people used to ask me, why do I prefer working with Google than AWS? I said that Google have a very, and not just here, but a very consistent way to work via API. So once you master one set of API at Google, the learning curve for mastering the other set of API, it's pretty easy. They're very consistent, and also you can see that in the way of you've got different services. You basically call them. So I think that's my dog that I've been talking to in the last 3 years. It's a coffee dog. So feel free to ask me now any questions, or catch me later on. I'll be more than happy to answer anything. Luke Skywalker, following on Facebook and Instagram. We've got 18,000 followers on Facebook. Yeah, I took a shortcut while at Meta. I received each month some ad credit, so I use it to promote his page.
Any questions for Aviv?
It's like a general question. We have a lot of students in here, so like this is a lot of amazing stuff. Maybe they have. Like if you're a student and you wanted to get started trying to use Cloud Functions or Cloud Run, any idea what the best place for them to start would be?
Documentation first, just the documentation there, with link to a lot of samples. Well, I took most of the code here from samples because I wanted to make it very simple. And I think there are some online, I forget the name of it's not Code Lab, what's the name of it? Yeah, there are some labs that you can take online. And again, if there are students here and want to provide, feel free to ping me. I'll be happy to help. I used to use, but I used to use that engine a lot in the past, but I moved away from it. And they have different, the standard, a different standard, and the offering was confused, and you have to do all kinds of tricks to work with things. And going, and if you're working with function, basically your code is very portable. Well, with the exception of the wrapping up the function with the calling mechanism. But when using App Engine, you have to use their own specific libraries, etc., which is not very portable and more vendor lock. At that time, it was a great offer, but the world has been moving. Also, I think the pricing model is a bit easier when using Cloud Function, etc.
It looks like, so with all the different options becoming closer in feature set to Cloud Run, so
yes.
What's your recommendation for use cases between like Cloud Run versus like multiple Cloud functions behind an API gateway?
That's a good question. You have more flexibility when using Cloud Run. Some of it will come to Cloud Function, but it's lagging. So it depends. If you need a small, relatively set of function, go for Cloud Function. If you have a lot of function, that managing a lot of function in Cloud Function, again, sorry for the wording, it's a bit overwhelming because you need to deploy 10, 20, 50 functions, and you have to manage. If you Cloud Run, you can have your application in one instance, and that's it. So, like, it's the case of microservices. It's manageable until a certain number. But once you go to 100 to 1,000, you start doubting whether should I be moving to microservice architecture. But there isn't any one good answer. Again, it depends. But I would certainly start with, if I'm building a small application, I would start with the Cloud Function or Cloud Run. Just a while ago, it took me probably less than a day to migrate application that was running on a VM instance to Cloud Run. And I did it even to write a Docker file. And if you are not familiar with Cloud Build Tech, I suggest that you use it. Cloud Build is a service by Google that builds your application. You can give him a Docker image to build, but if you're using the pack option, basically you don't need to do anything. It will look at your application, understand, and create its own easy-to-use Docker file behind the scene. So no custom Docker file, no separation between build and temp, etc. All taken care of. So again, another. So I think we're out of time. Feel free to catch me. I'm here, happy to answer anything.
Can you make sure you share from the
okay.
Joe, can you unmute your computer? We don't have any audio here. I think we got some audio.
Linda says we're good too? Okay.
But nobody can hear me.
We are getting ready. I think they can hear you online.
Oh, okay. All right.
You'll speak up for people.
I guess that's all that matters.
Okay, we're getting ready for the second session here. We're very happy to welcome Terry Riopka. Is
Yeah, good.
pronounced
Yeah.
right?
Yeah, great.
Dr. Terry Riopka from Aware, who I'll remind everyone is one of our sponsors tonight. They have provided all of the food for the event, so we're very thankful for that. And we'd love to hear Terry's talk on the intelligence of mobile biometrics. And let's have it.
Okay, great.
Thank you.
Okay, good morning. So I know a lot of you here are here to learn about about new tools. Well, I'll speak up. Okay, so I know you're here to learn about new tools in this field. I'm gonna talk a little bit in a more general way about mobile biometrics, the development of mobile biometrics, and how that might inform the development of remote intelligence systems. Okay.
Could you also just give us a rough idea what the topic is?
Sure. Okay. So, so my name's Terry Riopka. I'm the director of research at Aware. So Aware is a biometrics company. So we've been in the area for about 30 years, actually. And we've developed various software. All our code is developed in-house. We've developed code for face recognition, for fingerprints, for iris, we've used behavioral biometrics, and most recently voice. And we've also done work in text analytics as well for entity resolution. So we've done a variety of different types of work. We've got a lot of in-house IP, and we're trying to extend that into various commercial areas. Now, I can't seem to go to the next slide here. So this is just So this is just an overview of what I'm going to talk about today. So I'll talk a little bit about what we use biometrics for. I'll talk about some of the enabling technologies for remote intelligent computing in general, and then I'll present biometrics as sort of a case study. It touches on edge versus cloud computing, so I'll discuss that, and then I'll talk a little bit about what it's like developing under the constraints of mobile and the mobile environment. Okay, it's still not switching. It's still not switching slides.
I think your mouse is on the wrong screen. That's why it's not. So if we go in the PowerPoint, click on the screen, and then we.
Okay, so we've seen biometrics start being used in a lot of different areas. We've seen it being used for controlling access, attributing accountability in law enforcement and defense, and then personalizing services. We've been able to create very secure mobile ecosystems which are driving commerce by lowering the friction of user interactions and simplifying financial interactions. Mobile biometrics also spurred the expansion of on-demand infrastructure and the proliferation of sensors that are being used by these devices out in the field. So the reason there's been success in a lot of these areas is because there's been this sort of confluence of multiple factors. We've had increases in the power of computing hardware, both in the size of the hardware that's being used and the power of its computing capabilities. We've got ever increasing power available to us for computation. There's a lot of sensors being used by devices out in the field. They're cheap, low power, a lot of different sensing capability out there, and we also have obviously Wi-Fi and high bandwidth connectivity that allows a lot of data to be transferred. And then, of course, we've got the improvements in machine learning. The latest advancements in machine learning have drastically improved the capabilities of the algorithms that we can implement. And of course, none of that could be happening without the large scale availability of the data that's out there. So, of course, that's been the consequence of the sensors that are available out there, the sensors that are getting the data from the external world, and then of course the high bandwidth that's enabling that data to be streaming into computers that store that data and analyze that data and can manipulate it. And of course, I'll mention, this isn't related to biometrics, but of course you've heard about the Internet of Things. This is going to spur even more development in the area. As you're able to communicate with more and more devices, put hardware on smaller and smaller devices, and have all of that interact with the cloud. So let's talk about biometrics. So I just want to give you some idea of what's involved in mobile biometrics, some of the capabilities that we have to implement, how we implement them, how we divide those resources between the device and the cloud. So taking one application, think about enrollment or authentication, or where you're trying to authenticate your identity. So there's a lot of factors involved in developing mobile apps for this. So it's not as simple as just matching a biometric. They're not just taking a face and trying to find a face. There's a lot of supporting infrastructure that's necessary for developing applications like this. So one of the functionalities you need is, for example, auto capture. So you have to have on-device image acquisition, and you also need to have some sort of quality assessment in real time. So you need some sort of feedback to the user that's using the device. This all has to be user friendly, has to be fast and actionable. You want to provide information that's useful to the user, and you want to. This is all in order to get to create this low friction process. Because face it, if something takes longer than a few seconds, people start getting people upset and antsy, and so to enable this kind of technology to proliferate, you need to address these kinds of issues. Yeah.
When you're talking about low friction, what's the difference between user-friendly, fast, and low friction? Isn't user-friendly and fast the only things that low friction consists of?
Well, I guess you could. That might be a little redundant, but fast and actionable feedback I mentioned specifically because that's related to the information that you're getting from the device. Okay, so if you're talking about interacting with the cloud, there's going to be issues with that, right? So you don't want the latency associated with cloud communication in order to provide feedback for, say, quality.
That's included in fast, right? What low friction means besides user-friendly and fast?
Yeah, well, like I said, it's a little redundant, but low friction, obviously you want the entire transaction to be low friction, right? So you want a very smooth transaction. You want minimal required interaction between the user and the device. So yeah, you can think of these terms as somewhat redundant, but I'm just trying to make that point. Sorry?
It has to work.
Right. I mean, that's right. So there's different aspects to that, right? So it does have to work, right? Okay. So what else do you need? Well, in the case of authentication, you need some sort of liveness capability. So you need to be able to prove that the person who's using the actual device is the live person. And so how do we do that? Well, we have to. It takes a little bit more sophistication to compute liveness. In our case, we transfer image data from the phone to the cloud. We do some processing on the cloud, which then sort of looks at the biometric, tries to determine whether it's some sort of spoof potentially, and then it returns a response back to the user. And in a case where you might reject the user if you determine that the person is trying to spoof the system. So again, here you have this balance between what's happening on the device and what's happening in the cloud. And that's related to the amount of computation that's necessary to do the actual algorithms. And so in the case of auto capture, you have to do the stuff on the phone because you need that fast interaction with the user. In the case of liveness, there's more sophistication to the algorithms. They might take a little longer. And in our case, we've decided that we're going to be implementing that on the cloud. And then, of course, after this, you have any kind of multi-factor analysis that you do to actually match the biometric. And so this may include image data or may include some sort of sensor data or combination or even multiple biometrics. So in some cases, we use face and voice, depending on the scenario, the type of security that you want for the system.
My question is for the mapping that for
Yep.
the face. How much bandwidth are we talking about? What goes to the cloud?
Right. So in our case, and that's definitely a factor. And I'll discuss that a little bit in later slides. But generally, in our case, we're talking a stream of images, and of course we take some efforts to compress that data to minimize the size of that.
So like would a 20 will be used more, right? What about 60 or I need to have at least a 2G?
Well, I'll talk a little bit about that because that is a factor. And we've tried to move to different markets. So depending on the market that you move to, you do have to take into account that those kinds of issues. So we have made efforts to reduce the amount of bandwidth necessary to implement this. In the case of Africa, for example, we've done a lot of business there, and in their case, the cost for sending data is significant, and so they want to minimize the transaction costs associated with that. And so, yeah. But in our case, we're talking a stream of images anywhere between 2 and 5. You know, 2 and 5, sometimes 10 images, depending on what we're doing. So, and of course, in the back end, you also have the possibility of having distributed processing for, let's say, large matching applications. So if you're matching, let's say you're talking about a fingerprint application for law enforcement, they might be matching a very large database of individuals, in which case they might do some back end distributed processing to enable that to happen quickly. Yeah?
So if your data gets stolen, you just replace the password. If your biometrics get stolen, what are you going to replace the face?
Right. Right. Well, that's a very good question. So there are a lot of different approaches to solving that problem. So one of them obviously is encryption. So to limit the ability for a hacker to take your data. Another one is for we've been working on recently, referred to as biometric tokens, and that's where it's sort of it's a cryptographic biometric method that's essentially obfuscates completely the biometric itself. So you could steal the face token and be unable to actually reproduce the biometric behind it. Yeah.
As you all know, anything on a blockchain is cryptographically encrypted, and yet there's plenty of hacks there.
Right.
But that's just your money. If your retina gets stolen, you're not going to replace an eye.
Right, right, but that's why there are these liveness detection algorithms, for example, right? So that's, in some ways, it addresses that to some degree, because if a person does steal let's face it, your face is available on the internet somewhere, right?
I'm not talking about face, I'm talking about retina or fingerprint.
Right. Well, in that case too, in order to use that data, they have to actually, in the case of fingerprint, for example, they have to actually create a dummy fingerprint in order to use that data to access your biometrics on some other system, right? So again, it's an instance or example where spoof detection why spoof detection is actually needed and useful. But that's an excellent question. Like I said, there are other approaches that we're taking to try to eliminate the possibility of even being able to reproduce a biometric.
Are you able to talk about them?
Not the details of it, but just the fact that we're working on it.
But not that's all you could say.
They're not as accurate. To be clear, they're not as accurate as actually using the biometric, because you give up some of that ability in order to obfuscate the information. But I can talk a little bit more offline if you're interested. Yeah. Well, no. We've decided not to, simply because it adds friction to the whole system. So we've been extremely successful in the liveness algorithms that we've developed. They are capable of detecting liveness of using actually individual images even, and they can tell the difference between pictures and videos and 3D masks and all sorts of things. So they've been very powerful, and so we've just haven't found the need for it. We've tried to avoid it, actually. And the other reason is because it's also they're less accurate, right? So they're less secure. So a spoofer who would, let's say you had a multi-factor ability, right, where you do both, they're always going to go the path of least resistance, right? He's going to know that the algorithms are more accurate, so he's going to fail on the algorithms, and then he's going to fall into the second tier of using the challenge response, and then try to foil it that way. You know, so spoofers always go to the least path of least resistance. Well, replay attacks, again, well, that's a more complicated one. You have what's called injection attacks, for example, right? Well, actually, you're talking replay attack is pretty easy because you're detecting display devices. So but when you're talking about injection attacks, that's where you actually take a stream of data and funnel it into it, you know, circumventing the acquisition device. Then you're talking about more difficulty. Right. The way we handle it is we have what's called, again, this is going into a lot more detail, but you know, we have what's called the bright screen algorithm, and that actually, sorry, it's called the bright screen algorithm, and what it does is it actually it flashes the user, right? So you actually have a flash imprint on the user, and so you're creating that connection between the transaction, the real-time transaction, and that's something actually physical on the 3D scene, right? And that connection connects the transaction and prevents injection attacks, because you have to have that in order for you to be clear that the event that you've captured is a real-time event on the device. So there's a lot of aspects to that are very interesting. Okay, so let me continue here. Okay, so, and of course, surrounding all of this, you know, you have to secure these transactions. So you have to have encryption in a lot of different areas of the system. Okay, so this thought about, you know, when you see these terms edge versus cloud computing, it makes it sound like it's an either or, right? So in the case of biometrics, it's definitely not that, okay? It needs to be some combination of the two. And so how do you decide about that combination? Well, you have a lot of system issues that you need to deal with in a biometric system. So one, obviously, you're concerned with accuracy of the algorithms. You're interested in response time. And so you have the system response time for the entire transaction, but then and then you have algorithms. Oops, sorry, let me go back. So you have algorithm security, and again, security here in this case is there's always this tension between security and convenience, right? So the more convenient you want the algorithm, the less secure it typically is. And the more secure it is, the less convenient it is. And your accuracy determines the overall relationship between those two. So that's a very important set of factors. And then you have data privacy and security. Obviously, that's encrypting the data. And then is there a way to obfuscate it or prevent somebody, even if they get it, from using it? And that's what this lady asked about. And then you have, obviously, communication bandwidth, data limits for the environment, right? So if you're deploying this in Africa, for example, there's more stringent limits on bandwidth that you have to consider in that marketplace versus if you're deploying in the US, let's say. Operational configurability. You want to be able to configure the system. You want to adjust thresholds, let's say, to adapt to different scenarios, and of course cost, and that's always a big factor. So you have these system issues. There's different ways to get to the same point using edge and cloud. And how do you decide between the two? Well, you have computational resources, so you have certain limit on the device, certain limits on the cloud. In the case of mobile, you have a lot of different phones out there, right? And those phones could be pretty old. They could be as old as 10 or 15 years. So you have to think about the possibility of those phones implementing your algorithm. On-device application footprint is extremely important for some markets. You can put a lot of stuff, okay, so you know yourselves, some of the TensorFlow models can get very large. Putting that all on the phone, even though the phone can handle it, it may be an issue in some markets, right, where if a person needs to upload or update an application, they don't want to sit there for an hour downloading a 200 megabyte application, even though the phone can handle something like that. So those are issues, and those are mostly economic questions. And then you have, of course, response time you see here in all three areas, right? You have response time for the system, response time for edge for the phone, and for the cloud. It clearly depends on what you're doing, right? If you're doing real-time feedback, quality feedback, you have issues about response time on the phone. If you have liveness on the cloud, you have issues with response time there. And then, of course, the overall system response for the entire transaction. And then version update policy, again, that affects how often you download, the size of the package that you download. These are all relevant points. And on the cloud, some of the main ones that are slightly different are throughput. So if you have the cloud doing a lot of, let's say in this case, liveness computations, you have a lot of transactions coming in. So you have to be able to handle that. And so degree of parallelism that you include on that side, these are all issues that you need to deal with and in the final design. So you might think of this as sort of a tug of war between the two, and it's really better to think of it as a collaboration, right? Because ultimately you decide on the optimal uses of your resources based on the application or the scenario that you want to operate in. So let's talk about a little bit about the developing in this environment. You guys are going to be working on a lot of different applications, but as you start working on complex applications that require this interaction between mobile and cloud infrastructure, you need to consider some of these issues, right? So transaction logging is extremely important. Okay, so this is basically documenting or being able to look at the data that's coming in, right? So for data monitoring purposes, right? You want to know during development and then even after development. So a lot of these tools make it to our customers, right? So so we give a lot of these data monitoring tools to our customers so that they can monitor the progress, they can collect the data, they can analyze the operational statistics of the performance, and so they can provide us feedback, right? They can talk to us and tell us about how operationally the system is working. It's extremely valuable for us as developers to know how the systems are operating in the field. And then data collection for testing, training, post-deployment. That's extremely important. You want to be able to store that data, potentially using it for training or testing, and I say post-deployment because some of our customers that we collaborate with save this data and eventually come back to us and say, hey, if we give you some of this data, can you improve performance of the system? And the answer is often yes, and we do that. So what else do you want from a system that you're developing, right? So what you want is configurability for system parameters. You don't want to keep rebuilding all your apps all the time. Right? When you're developing this complex system, you want to be able to also incorporate the ability to configure it for certain parameters, right? So you want to optimize the system over time, and you don't want to keep hassling software engineering to keep redoing builds all the time. In larger environments, software engineering is not just doing your project, right? They're doing a whole bunch of other things, right? So for you to get them to work on your stuff can be problematic sometimes, and so and you have to remember, I'm talking from a research standpoint because I need to get to develop the algorithms and to implement. I need to interact with software engineering to get them to do a lot of the things that we need done. And then I talk about ground truthing. Machine learning is just becoming a part of the world, and so you're going to have this data coming in regularly, and you're going to want to use that. And in order to use it, you're going to need to ground truth it with consistent and expandable labeling. So you're going to need resources, either human resources or automated resources, to provide that ground truth thing. And you probably want to do it on a regular basis because your data is coming in all the time, and you can't just say all of a sudden, hey, tomorrow I need 1 million images ground truth. So you need to plan ahead, and you need to provide an environment in which you sort of maintain this sort of regular system. And of course, data storage, these are mundane things, but really they're important. You need to be able to properly name the data. You need to have it stored in proper places. You need to also maintain independent test sets. Okay, so we keep maintaining independent test sets as we progress with our development, so that we have sort of test sets from a long time ago that we've kept independent of everything else, and that's really just to monitor the progress of the algorithm. So that's extremely important, and it needs to be considered. Yeah.
As far as training data and labeling, do you have any benchmarks, or can you comment on like the ethics and implicit bias that might come with the machine learning and labeling stuff in AI, as far as like skin color, ethnicity, race, or any of that? Do you have any data on that, or do you have?
Yeah, so that's a very good question. So our company actually, we take a little bit of pride in the field to claim algorithms that actually try to address those issues, right? And I'll give you an example. In face recognition, for example, we don't do that well. There's this sort of national FRBT test for, we don't do particularly well on the main, in comparison to a lot of the vendors. We're not horrible, but but we're top tier in anti-bias. Right? The reason is because the specific algorithms that we implemented actually make use of classifications that are not race oriented, right? So they're more face structure oriented, right? So whether you have Asian background, or you have African background, or Caucasian, there's sort of common characteristics to faces that you can talk about without talking about race, right? You can talk about a large nose, for example. You can talk about certain features on the face, and in some way, and you can have sort of race agnostic features that are sort of more general, that relate to the structure of the face, and that helps you design algorithms. And if you incorporate that into your actual algorithm design, you can mitigate those kinds of biases. The other thing is monitoring the bias, right? So if you have properly ground truth labeled data, you can monitor that bias by doing experiments, and we do that all the time. So we have empirical tests where we try to identify what those biases are. And they could be gender, they could be race, but we do make an effort to try to mitigate those biases.
So you're saying you can accurately separate facial structure, which can be so closely tied to like ethnicity,
well,
and have be agnostic?
Sorry, let's say that again.
Facial structure.
Yeah.
Right, like people from different places look similar to each other, right? So like the structure can represent a particular subset of people. So you're saying that like it's agnostic to that, and there's no implicit bias in like the structure that might represent a certain subpopulation, for example?
Well, that's maybe an academic question, but the fact that we have been able to get top tier algorithms with minimal bias, even compared to very accurate algorithms, is, I think, relevant, right? It suggests that maybe there is something to that approach. Yeah.
Could you talk about the protocol for data storage?
Talk about critical data storage. What?
Protocol for data storage in cases where you're dealing with healthcare data.
Healthcare data. Well, we haven't really dealt with healthcare data per se.
It's not used in healthcare. It's talking about like HIPAA and things like that.
Okay.
HIPAA is like the healthcare patient with privacy.
Oh, yeah, we don't really have that much experience with that, so I can't really comment.
Do you know of any application where you use the biometrics and healthcare data? No, he had mentioned that they are used in healthcare settings.
Well, I guess I was more generally just talking about applications, possible applications to healthcare, yeah. But no, we're not currently. We've done some authentication applications in healthcare. So where they're related to access control. So it's sort of tangentially related to healthcare.
So how does like this Okta or two factors? So how can you integrate this instead of having the push notification or into the code? Use your application like a biometric into Okta. Have you done something like that?
No, Okta? I'm not familiar with that.
Like or you have the Google Authenticator, right?
Yeah.
So instead of using the two-factor code,
yeah,
you use the biometric.
Right. So what's
have you done that? So like, for example, just how many companies have the two-factor authentication, right?
Right.
You log into a website,
Right.
and then they'll either get a push notification on your mobile phone.
Right.
And then you either.
You're asking if we've done that?
Yeah.
So we've collaborated with partners who implement that, right? So a lot of the technology we sort of provide a lot of the pieces that they put together in order to do that. So so I would say yes, but beyond that, I'm not sure what your question is.
No, I'm just asking.
Yeah.
So it's not part of the base. It's like you're like the TensorFlow libraries, and your partners are using TensorFlow libraries. Right?
Well, we used to do mostly that, but now we've expanded to actually providing on-demand authentication services. So, in fact, a lot of the services that I'm talking about, we actually provide as microservices in a SaaS infrastructure. So, so we're moving in the direction of doing that. So we're
Are you like a snowflake like for biometrics in which I just say, okay, I need this on demand?
Yeah.
And take care of that. I don't need to set up my
Exactly. So we set up all the services that you might require. So you decide, okay, do you want face and voice, or do you want face and some sort of push notification, or do you want whatever?
Then I have to set up my, like in AWS language, my own VPC, or you're like a snowflake?
No, we handle all of that, yeah.
You're a turnkey.
Yeah.
I give you the response, request, and you give me a response, yes?
Yes, that's correct, yeah.
Okay.
Yeah.
We've got like 5 minutes for.
Okay, yeah, we're coming to the close, I think. Okay, and then finally, one last point about the need for simulators. So you want to be able to analyze all aspects of your data processing pipeline offline. Okay, so you don't want to have to rely on the operational system. You also want to be able to reproduce operational data out in the field. So if a customer says, "Hey, this set of images came in and it's giving you the wrong answer," you want to be able to take that exact stream, put it on your local system, and be able to simulate the results. So that's extremely important. Okay, so for algorithm enhancement, so this is from a research standpoint. I talk about this. There's always this tension between the footprint on the device and improving performance. So that's constant tension for mobile development. And I have here is, I say you need to regulate the pace that you do the optimization. And this is really kind of a nuance, but it's important, right? Because as a researcher, the last thing you want to do is completely optimize your code on the mobile device from the very beginning, right? Get it as small as you can, as fast as you can. I mean, you think that that's like what you would want to do. But if you do that, then especially in the early stages of algorithm development, you get kind of tied to that, right? So the next time you say, hey, I've got a really great idea for an algorithm, but it's going to cost me a second longer on the device, that's a tough sell, because now all of a sudden things are going to get slower for the customer, right? And then you're in a spot, right? So the idea is not to. This isn't the tension. The hope is that you can plan this out a little bit, right? So you don't want to push too fast on the optimization side, because then you're really limiting on your algorithm improvement side. And that's a really important lesson that's hard to learn, because there's always pressure to do things as fast as you can, as small as you can on the device right away. And this is also, there's no substitute for being in the world. Okay, so being able to have your algorithms run in the world, in the operational scenario as fast as you possibly can, because that's where you learn the most, and that's where, oh, that's great. Okay, I have to hurry anyway. So you want to minimize the impact on software engineering. It's important to have good, tight, iterative development cycle with them in order to enable that to happen. And then finally, it's good to have a good working relationship with their customers, because this lets you, they can supply you with data, they can supply you with feedback. It's very important, and it's something that needs to be needs to be done. Finally, I just want to add on end on a note, sort of a loftier note for you guys. I date myself a little bit here, because when I was a kid in the late 70s and early 80s, the future was the year 2000, okay? That was, for me, that was the future, right? So now it's been delayed a little bit, right? So it's been delayed, I think, maybe by about 30 years, something like that. But at least it's getting here, and I think it really is here, okay? So the future is here. You guys are going to be part of it. We're going to be developing applications, because of the hardware availability and the new algorithms that are out there, specifically the machine learning algorithms. There's going to be a lot of different motivators for this progress. And this is just a brief list of things. Stuff that's I call it low-hanging fruit, but there's a lot of the low-hanging fruit, okay? So this technology that we have now is going to last for a long time. I mean, when you think of, in terms of these AI winters, where you have sort of, hype, and then these AI winters, and then more hype. This hype's going to last for a little while, because there's a lot to do, and the algorithms are getting extremely powerful. And so there's going to be a lot of really fascinating application developments in the near future, and you're going to get this slow. We're going to have this slow migration of machine learning to the edge. Okay, it's going to happen, and when that happens, it's going to be really fun. So that's it. Any questions? Yeah.
At the beginning, you mentioned behavioral biometrics. Is that related to just like from the neck up if you're doing a face recognition, or do you other stuff with like body locomotion or certain movement, or like, I guess, what does that mean? I'm just curious.
Right. So mobile devices have a lot of different sensors on them, right? So they have accelerometers, they have gyro sensors, they have location sensors. There's a lot of data that can be leveraged for different applications. So that when I talk behavioral analytics, I talk about leveraging some of that data in conjunction with other behavioral information from images.
So visual and whatever the person is
Right.
doing with their device, so to speak.
Right.
Have you used anything specific that you can talk about?
In terms of behavioral? Well, we've dabbled in a lot of different use cases. So cases where it was specifically related to spoof detection, right? So there's certain behaviors that can potentially be abnormal for spoofers. So if you give that a little thought, I won't talk about it, but if you give that a little thought, you could think that there's certain physical behaviors that you might use as telltale signs that somebody is trying to spoof a system, right? Something as simple as, you can think about it yourself, just twisting the phone right? That's not a normal operation that you would do for spoofing, for normal image acquisition, right? So if you're, so even something as simple as that, you know, you can potentially use for detecting spoofers. You know, that's just one example, but
Do you think if they're twisting it to look at something else, or
yeah, I mean,
because that's like
I mean, if it's a banking transaction, right? I mean, you don't expect the user to go like this, right? I mean, it's a little weird, right? So, you know, and a lot of this is risk analysis, right? So banks and financial institutions aren't necessarily interested in answers, like precise answers, like yes, reject this person. They might be just interested in knowing, is this a risky transaction, right? Because then I'm going to limit how much money this guy can take out, you know, in real time, right? So they can say, okay, this is a risky transaction. I'm going to let him only take out $100 or $200 or something like that instead of $1,000 that he's asking for. So, well, okay, I'm dead here. Oh, yeah, through the email. Yeah.
So we're just getting ready for lunch right now. I just wanted to let everyone know we're going to have a break until 1:15, and then we're going to be back in this room for a few more talks this afternoon. What's that? Sure. Yeah, we're not going anywhere. The lunch is just going to be right outside here.
Okay, hello, hello.
Okay. We are getting ready to get started here. We have Mikaeri here who has come to join us from Brazil. No, she's going to be talking about creating scalable ML solutions to support big tech's evolution. So I'm very excited. Thank you so much for coming.
Thank you.
And the stage is yours.
I'm so happy to be here. This is my first talk abroad, so a lot of special moments for me. So have you heard about the story of data scientists that wanted to deploy his experiment to production? I heard a lot of stories like that. So a data scientist that wanted to create an experiment, it was very nice, but there was a time that I wanted to real data come to my experiment. So when this happens, a lot of challenges come to the table. So that's what I'm going to talk today, and I do want you to enjoy the talk with me. So who knows about the DevOps? Is it familiar for everyone here? Okay, right. So DevOps is more than a framework. It's more like a culture. You want to put the best practices in your application to leverage the best value that you can have. So DevOps is like plan, code, you test your application, release, you deploy, you operate, and you monitor. Okay, but when it comes to data, what do we have? We have MLOps. So as well as important to track traditional software that we have at DevOps, we also need to track our machine learning products. So it's not about just creating an experiment using linear regression. It's one of the most famous models that we have. But not just that, you also have to monitor, to configure, to automatize that, to do feature engineering, verify your data, collect your data, testing and debug, resource management, model analysis, process management, metadata, monitoring, serving infrastructure. And this is just components that I'm linking here, but there's a lot of things depending on the domain that you're working with. It's not just about ML code, as some of you may think that it is. And this is from Google. They have a very nice article where they mention about what are the levels of machine learning that you can have machine learning operations. And one of them are this one. I'm not sure if the level 2 or the level 1. You can have like machine learning being done manually, where you have to activate to start your model manually. You can have machine learning with CI and CD, when you can continuously integrate code to your model. As soon as you do a change in your formulas or your model, you can also retrain your model automatically, and as well as you can retrain your model based on events. So let's say you just had new data coming in the bucket or BigQuery, and then you can retrain your model automatically. So this is one of the types that you can have of machine learning operations, and this is why we do that, because you have a data science theoretical workflow. So you have to understand the business right after you understand your data, because one thing is understand the business that you're working with. And after you get the data from the customer, they give you the data, and you have to understand, okay, is that enough for me or not to start creating my product? After I understand the data, I can prepare the data, and I have to do that because my model will not understand the data as I got from the way that I got from the customer. Prepare my data, doing some scaling, a lot of feature engineering. I can start modeling. That's the part that we have a lot of hype on the machine learning models and so on. But in fact, this represents 10% of the entire pipeline, because if you don't have good data, you will not have a good model. This is very important. And right after, you have to evaluate your model, deploy that, and suddenly you can see that maybe your metrics are not that good. So you have to maybe retrain your model, doing some hyperparameter tuning, or you're going to have to talk to the customer again because, man, the data was not good. So it's not the problem of the model itself. It's a problem with the data that I have. And here I'm addressing some of the main challenges that we have in machine learning. So one of them is how to move my experiment to production. I would say that this is one of the main challenges that I faced during my career. As I haven't told you before, but I was a data engineer, I was a data scientist, a machine learning engineer, after being a software engineer for a while. And when I was working with data science, I already knew about Kubernetes, deployment, and all this stuff. But my colleagues that started their career as a data scientist, they were not familiar with these topics. So it was very challenging for them to understand how to move their experiments to production. It depends on your background. I mean, it was easy for me to understand how to move a model to production, but quite hard for me to understand like calculus. I had just calculus 1 and 2, like they had like for 7 calculus, and I was like, oh my god, I will take a lot to learn about that. So every person has their own challenges, but for me it was not that hard to move the experiment, but create experiment was hard for me when I started my career in data science. The other challenge may be data with large amounts of storage that grows frequently, often places in blob storage. So you have to version your data set. You had to put some versions about this data set. Let's say that you had to come back to the customer and ask them again to put more data, or give me more data, another data set I can join, and then create a brand new data set that will serve your model. So you have to create some versions of that so that you can understand, okay, my model performed better with this data in here. And this data was the one that the customer gave me when I asked them, because I was not getting the best results and performance. So if the data is not organized correctly, there may be a data leakage where your training data is contaminated with external data. So I don't know who that are in here already worked with machine learning. Okay, so who knows what is data leakage? Okay, so in machine learning, it's very important to mention that we have different splits of your data. So let's say you have a data set and you are going to split this data into train, test, and evaluation. So this is one of the types that's of splits that you can do. Your model is like a child, and this child can learn about something for like an exam, but this child cannot understand just the right question to this exam. So let's say the professor changes a little bit of this phrase of the question. The child will not understand anymore and will not be good in this exam. So when you say data leakage, it's like my model should be able to generalize different questions that the professors can ask for these children. But the good thing is that we cannot let our model see the test data, because test data is my real world data. So my model should be trained with trained data. So let's get a data set. You split 80% will go to trained data and 20% will go to test data. From this starting here, my model cannot see the test data, because test data we are going to see how my model generalizes with real world in the test data. So during training, you cannot see test data. And after that, you can also have a challenge about how to use the best features for my model. So we're going to have a huge data set with a lot of columns. You have to decide what are the columns that will become features for a data set that will be better for your model. When I was starting, I thought that as much features I have, I will have a better performance. So let's say 42 features is good. My model is, it's the best one that I have in the company. But it's not like that. I mean, today we have some algorithms that help you to understand what are the features that are the better for you to use in your model. The features that are more meaningful for your formula and so on, because data science is about math, to be honest. And when to retrain my model, how much historical data should I bring? So we have to have historical data, and as much data we have in terms of rows, not in columns, my model will perform better. How to identify data drift. Data drift is a concept that's very important when you go to a data science path. Data drift is basically, let's say that you train your model, so you have a data set, and your data set was good, you train your model, you test that in production, it's okay. So you you kept this model in production for a while, and then you saw that this model started to not have the best performance. So what happened? Because I tested that before going to production. I did some unit tests and also a measurement about the model specifically. And what happened is that my data can start changing, and it can be detected by distribution. You can plot a distribution for our data and understand that the market is changing. Let's say you created a model 2 weeks before the pandemic. So you were, my model is very good. And then 2 weeks ago it crashed. Why? Because we had a different, a huge event in the whole world that changed a lot about your data, the data that's coming from. So predicting the customers that you're gonna arrive in your small store are not gonna be the same as the pandemic, for sure, because we had a lot of lockdowns and so on. So, and model drift is even worse because, imagine that you know that the data is different because of the market trends and so on. And model drift is that not just the data, it's not about retraining my model with this new data that will be understanding the new behavior of markets. But model drift is more related to, I had to change the approach that I have because my model is not suitable to my problem, the thing that I'm working with anymore. So it's very important to understand these two topics in here, and not just that, manage distributed clusters across multiple pipelines. So data scientists, they may have difficulties on that because they have a lot of things to learn about models and so on. So distributed clusters, do I really need to manage that? There's a lot of difficulty for me to learn that. Machine learning, with numerous machine learning models running at the same time. So when you go to a company that's like a big tech, you are going to see that maybe your problem, it will need more than one model. So let's say like a recommendation system. We'll need like maybe a segmentation. You're going to segment your clients, and from that segmentation, understand what type of product should be addressed to each group. But it's better for you maybe to have a group recommendation instead of each customer. So you would use like a clusterization algorithm right after you use like a regression algorithm, or something more specific for recommendation, like SVM or so. And not to mention about the deep neural networks, that is something that's very important and very used in these companies. And this tech that changes quickly and frequently. So Google Cloud has a lot of products, and you can check that in the website. And what is nice that I was checking that we have a use case in here. So Google split this by use case. So AI for data scientists, and here we have a product that we will be talking today. That's Vertex AI, because here I'm gonna tackling a different challenge, that is how to get my model and put that in production. Different from the AI for developers, that if you see, I don't know if you guys are seeing, but we're having here more APIs that are focused in developing models. That we're going to make it easier for you, because we see that AI developers, they have a different approach. They want to help with APIs that are going to help you with the model itself. Because, create an end-to-end pipeline is something that maybe is easier for you to work with Kubernetes and so on. And you also have a lot of libraries like text-to-speech, time series, that's very important as well, translation, video AI, vision, and so on. And AutoML is very nice as well, because you don't have to test a bunch of models. You give your data set and what your feature that you're aiming to to predict, or what's your purpose with this data set. If you want a recommendation system, or if you want to separate your data, and then AutoML will give you the best model according to your data set. Okay. And we also have AI infrastructure. So containers, you have images for your machine learning models. Here we have a lot of deep learning things that is gonna be used for you when you want to use deep neural networks, problems that are huge, like computer vision ones, or natural language processing. Okay, ChatGPT maybe using different. Okay, yeah, I know. And I forgot to mention that this slide in here, I use Midjourney. I don't know if you guys are familiar with this thing. It's very high right now, but I just asked them a fox with a fantastic world with an astronaut suit, like the thing here, and it came like this. I like it a lot, and I put that in here, but I forgot to mention. Okay, so yeah, Vertex AI here. We're talking about that. I have a demo as well. We are gonna see it live. It's Google also. Here I added is the next generation of AI platform. So if you are familiar with AI platform or Kubeflow pipelines or TFX, that the TensorFlow extended, you will be familiar with this one. Because Google wanted to remove from the data scientists the need of manage a lot of configuration files, a lot of Kubernetes, a lot of containers, and so on. Because they want you to focus on what matters, like the model, the data itself, developing this code, and let Google manage this part of the infrastructure. But even Google managing that, they allow you to change that. So it's flexible. If you need to change something manually, you can do that, of course. So it's very nice. And as I mentioned, if you are familiar with Kubeflow or TensorFlow Extended, it'll be easier for you to work with Vertex AI, because they got basically when you are using AI platform, you're gonna see like a label right now saying that Vertex AI is the next generation of AI platform. So you're gonna migrate, and you're gonna see that's not that hard, and not just that, but the pipelines. That's something that I'm gonna present for you today. Is you have to pay for each run that you do, so it's cheaper than it used to be. And I guess it's very, very nice this point. So what is included in Vertex AI? So here I'm presenting to you like a workflow of machine learning. So we have data witness, feature engineering, training, hyperparameter tuning. So it's important to mention that we have parameters. So let's say we have a function, a linear function. The parameters of this function will be created by the model, but you can manage the hyperparameters. So you can manage how will be the training of your model, how many layers, for instance. If you're gonna use, what is the cost function that you're gonna use? A lot of things are manageable for you. The model serving, the understanding, the tuning, the edge, the model monitoring, and model management. So here you have AutoML that will be helping with you to choose the best model according to your data set and your purpose. You have vision, video, language, translator, and you have tables. Data labeling, feature store, a bunch of topics that I'm gonna go deeper with you. So here is Vertex AI. So Vertex AI has this interface. You're gonna see here that we have a lot of topics that we're gonna go through today. But the various I'm going to talk about it right after. So here we have the interface, a lot of parts that you can take advantage depending on your use case, depending on what fits you better. And we have the data set. So data set is important for you because you can put a version about on the data set that you're using to train your model, so that you can track the best model. Okay, this version 2, with which data it has been trained. So then I can retrain and have personalized that I can redo them if it's necessary, you know. Also, we have feature store. Feature store is a very important topic. Because let's say that we have a bunch of models in our company, and this is gonna be something very present when you go to big tech. You have a bunch of models, and all these models use the same feature. And this feature was difficult to be created. You had to aggregate a lot of columns, you had to place a lot of transformations, and then you end up with a feature that gives me like the last 5 days of orders from the customer by the week of you have a lot of things that you aggregate. And then this feature, one part would be okay. You can, I mean, do this coding every time that you're gonna train your model. Or another thing that you could do is create a method that will be called when you are going to train your model. So you have a transformation step before training your model, and you're gonna call this function. Or you could use a feature store. That's basically you're going to transform this transformation. You're gonna get this transformation here to put as a data that will be stored, so that you can track, okay, this feature here, in which models we are using this feature, what is the version of this feature, and so on. And use like time travel, there's another concept very present in data as well. So it's very nice feature store, but I don't recommend you to use in every use case. So like I'm gonna train a model, I just have one use case that uses this feature, I'm gonna put it in the feature store. No, it's not like that. You're gonna just think about the feature store when you have really a lot of models using the same feature, okay? And it's very nice. And you also have yeah, you can monitor your data as well. We have labeling tasks. So when I was working with COVID-19, I had to work with a computer vision problem to understand if this image was pneumonia or a COVID. But I'm not an expert to say, oh, this is COVID, this is pneumonia. In fact, I saw like an image with a blank space. I was like, oh, okay, this is something that I don't know what it is. And then a doctor came and helped me say, okay, this is COVID. We had to have this people helping us to put this label to the data, and then we can put this data into the model, okay? And labeling task is something very nice because you can create a document, okay? And it will be given to Google, and Google will understand with human labelers how can they help you following this instruction. So let's say, example, write a bounding box on each player in a clustered instance. So let's say you have a model that you want to segment the players. So you want, you have a lot of images, but they're not labeled. You don't have like the number of players in these images. So you want Google's help to put that things in these images for you. So you're gonna say like produce 5 bounding boxes of the for the 5 players, and then Google will help you with doing that. But you have to give an example, and then they're gonna be able to do that for you. Another example would be only annotate players in the field. Don't annotate anything on the panel. So here will not be annotated, and these ones would be. Because if you say like I want to have a bounding box in the players, if I'm a person without instructions, I would put a bounding box in the guys on the screen as well in here. So if you create this document, it's a PDF, you share with Google using labeling tasks, they can help you with a human help. So it's very nice. Work. Yes. Yes, actually, the labeling test in here is more related to human helping you to train your model. They are gonna label for you. So you're gonna send. That's the thing. You are gonna have to help them to understand your domain through this document. You have to put all the information that you have related to this because they also added in the documentation. We don't have a domain. So please be very specific in this documentation because what they are helping you with the workload that you have.
Maybe I'm not.
Okay.
I have got like 10,000 images. Okay. So I need to put those 10,000 images and see that I'm looking for this and I could have market.
No. Yeah. So you will do that without labeling tasks. But we're gonna give the images to them. You're gonna get one example from this data set that you have of 10,000 images. You're gonna put this example in the data in the file that I mentioned in PDF, and you're gonna say, okay, how are you gonna proceed with this labeling? like this example that I showed.
Go to the football thing, right?
Yeah, so going back to this.
So the right one. Let's say the like example of the right one.
Okay.
Now I want to be able to graph that and annotate that this is what I'm looking for.
You are gonna do that.
And how do I do that?
Because you're gonna add this, write a document. You're gonna copy this image. This is I add in this slide. A PDF document, share with them together with the images. So you're gonna write, they say to you, we don't have the domain, so please be very specific. So you have to write like with natural language, saying like what do you expect to them to annotate, because this is gonna help with this workflow that you would have with 10,000 images. So that's how it works. We have the workbench as well. Workbench like if you're running experiments, you are familiar with notebooks, like Jupyter notebooks. You have Collaboratory that is from Google. We have a lot of notebooks that help you. It's like an IDE where you can create your code and also write your findings. You have text cells and you also have code cells. It's very nice and very used when you're gonna create some experiments with your data and also with your models. So Google has a workbench that's like an environment where you can add your notebooks in here, but not just add your notebooks. You can also create a solution running notebooks. So it's very nice. And you have the pipelines that's where I'm gonna go deep into the demo. Pipelines is the part that I love the most because it helps me to create the MLOps solution that I want to. You connect some components, and this creates an end-to-end pipeline that will help you to leverage from the solution to production. You have the training, so you can train your models in here and create some experiments. Register a model. Why do I have to register my model? Suppose you train your model, you've got a very nice metrics, and you're gonna retrain this model. But then the metrics from this new model, they are not that good as they used to be from the last version. How can I get this version for the model that I just trained it? You cannot do that if you're not registered your model. And also, model registry is an artifact. You're gonna get this artifact in here, and they are gonna be used to ask more questions and you go to production. So let's say you're gonna we use this model for real users, right? That's your purpose, to be honest. And then you're gonna get this artifact and do a prediction. A prediction is gonna ask with real data, okay, let's say house prices. I have this number of rooms, I have this number of pools, I don't know, and what is the median house value? Taking into account these parameters in here. So this is a prediction, and you would do with a model that has been registered, like a model saved. And also you have endpoints. Endpoints maybe you guys are more familiar with. Let's say you want to deploy your model, so you create an endpoint that will be used to be asked for us to ask for more data or to understand the prediction and so on. You also have batch predictions. So the difference is that in batch prediction, let's say you have a recommendation system. You don't need this real time. Maybe you just run this 10 a.m. only once a day, and then you could use batch predictions because it has been scheduled, and then you can run every single day this time. You don't want to ask every time a model. It's different from chatbot use case for sure, because chatbot your customer will be asking a lot of times, and you don't have this time specifically set. The metadata will be storing all the instructions of your model, more data related to that in the pipelines that you trained, and you have a matching engine that's more related to some vectors that Vertex AI helps you with large amount of data. They create the solution, and it's very nice. And I guess that you guys would be interested to understand it more. But let's say about Vertex AI pipelines, that's more related to MLOps that I was talking about. Vertex AI pipelines has 4 types of things that I wanted you guys to leave this room knowing. Components, pipeline, compiler, and run. So what are the components? The components are modularized tasks that may receive a parameter or artifact and produce an output. So saying like this is easy, and in fact, it really is. So what is an artifact? So you have a parameter that can be like an integer, a string, and so on. Or you have an artifact that can be a data set, a model, a metric, or a visualization. You have also talking about components. With a components decorator, you just have to put this above your code. It will be generated a YAML file. And this component can be shared, loading from files or URL. There are some predefined components that can be used that Google already created, knowing that maybe they're going to be very important for each pipeline that users create. And talking about the pipeline creates a flow with the components managing their connections, can be scheduled with other resources from Google Cloud Platform. The compiler gets its actually the compiler is the specs of the pipeline in a JSON file, so it will we are going to interpret the YAML file that has been generated from the component, and then we run execute in the compiled pipeline. Okay, so let's go to a demo right now where the things use it to crash. I hope it do not crash today. Okay, I have here the collaboratory. This is the IDE that I just mentioned to you. No, this thing is different. Google Colab. Yes, totally. Vertex AI is an MLOps solution. It can be used inside Google Collaboratory. You can call Vertex AI from there, okay? As well as the Workbench. So you're gonna, if you use Collab, you're gonna be familiar with Workbench from Vertex AI because it has the environment of Jupyter there. So it's very similar. Okay. So I will connect in here. You guys are seeing the screen here? Okay, nice. Because I. Okay. Let's wait. Okay, so first things first. I don't know if you guys are familiar with Google Cloud Platform. You're gonna go here and you have the Cloud Shell. Okay, so here you're gonna interact with the platform. I already placed some things to make it easier for us, but you would have to set the project in Cloud Shell. So I created a project already called Demo DevFest Boston, and then you would confirm this project here just with the echo command, enable some APIs so that the collaboratory can interact with the platform there. You're going to create a cloud storage bucket where you're going to be storing our model and other artifacts that we can generate and give permission. So that this is the bureaucratic step that you have to do before starting. And then you're going to run the dependencies. You're going to install these dependencies here. It's going to take a lot of some time, like less than 1 minute. Of course. I'll do that. We have 2 pipelines in here. I promise I'll be very quick. I'm just installing the libraries in here. And after we install the libraries, we're going to have to restart our runtime because here this is something that is free for use. Okay, Google Collaboratory allows you to test in the cloud, run Python code and other libraries that are important for you. With that, you can train your models using Collaboratory, a lot of things, and you can also take advantage of GPU. So it's when you need to run deep neural networks like computing, you can also use Collaboratory to help you with that. So it's almost finishing, and then you're gonna have to restart your compute to be able to insert our libraries. So let's finish. This is the interface of Vertex AI. So when I shared with you, it was like this. So here I have some, I had to prepare training data, some errors that I had, recent models, get predictions, and so on. Okay. Demonstration. Have you guys already used AI platform before? Not? Oh, okay. Vertex AI? Really? Are you using production already? Not yet, but you will have plans to do. Oh, Workbench. So you're running these notebooks there. Do you think it's easier to integrate when you're running your Workbench than Collaboratory, or you don't see that?
Vertex is much better than Coda.
Oh, that's nice. Because I'm running outside the Google Cloud platform. So what's your name? Harsh. Harsh is running inside the Google Cloud in the workbench in here. So it's very nice. It's when you can run notebooks inside the platform. Okay, I just ran I just installed. I will restart it one time in here, and then I will be. Sorry? Oh, you have to create a sense here. It's because I'm creating a hard time to show this other than I can do this later. Okay, so after we started the compute, I'm gonna import the libraries in here. So it's here this key FP's Kubeflow pipelines that I mentioned before that we run Vertex on top of that. We had to do an authentication thing here just to allow us to interact with our Google account. Okay, so you already know that. The Tupper project here is a project ID that I have in my account, and also I put a meeting here in the AI platform. So let's start the event. So here is the component that I just mentioned with you. So this is the decorator, and I'm saying that I will create a component that is going to prepare my data. I'm going to receive an expression that is a string, and then I'm just returning the expression, putting this in lowercase, and removing some spaces in the left. So I'm running this component in here, and I want a second component. The second component is going to use a natural language toolkit, the NLTK library that's related to natural language processing libraries that you have in Python. Is very nice when you're creating chatbots or working with data in terms of text. And I'm just running this to tokenize. So when you're going to run like a natural language processing model, meaning you're going to have to tokenize your data to create some vectors of that after, and then you're going to be able to ingest this in the model in a mathematical way. So I'm going to run this component in here, and then I create a pipeline. So this pipeline, I'm just putting some, I added a name in here. What is the root? What's the path of this pipeline? And then I define the pipeline. So this pipeline here has a remover task that's going to remove some spaces, and it's going to call this method in here. So remover task is the prepare with the expression, and then I have a tokenizer task. But this is going to be right after we remove. So that's why I have to put tokenize. But the parameter that's the expression here is going to be the output of the remover task, you know? So it's like a building block, actually. I'm going to run this, and then I have to compile. As I mentioned before, you guys, if you have to lead this presentation with just 4 things, is the compiler, the run, the components, and the pipeline. So I run this pipeline job, place the name, the place path, and so on, and I put job.run. This is gonna trigger a pipeline here in Vertex AI. So I have a pipeline that's gonna refresh here to appear. Takes some minutes. Okay. Oh, it's already there. I haven't seen. This was quick. Okay, so we have this pipeline here, and I go here. I can see like my prepare and tokenize. So it's as I planned it. So the tokenize is gonna run after the prepare because I added in the tokenize in the input. It's the output of the prepare. Okay, so let's go to the demo too because we're gonna we want to get the things more complicated. So now I'm gonna talk about something that's more close to a real world scenario. Like I'm gonna have to ingest and prepare data, train your model, evaluate this model, and check if it's time or not to go to production. Sorry?
I have a question. Why did we need to restart the terminal for running the code?
It's because we have an issue about the version of the libraries. I don't know if they have that. They are fixing, I guess. So, but it's a workaround, if you know what I mean. And I was searching on Stack Overflow, GitHub issues. It was the same thing. Like, do that, and right after, we're going to fix. Okay, so that's what I did. Okay, demo pipeline. So let's go through this example. Importing some dependencies, and now I'm going to talk about data. So the data preparation step could go in here. I'm calling just and prepare. But it's important for you to understand that we have to deal with the preparation right after you ingest your data, okay? But in terms of just doing a quick demo here, I'm not taking care about the steps so much because I want to focus on the pipeline itself. So I put the component in here. I place as well the packages to install because I want to install pandas. That is a library that will allow me to interact with data. And also I want to manipulate that and scite2learn. That is the library that will allow me to get my model and work with that and split my data and so on. So in ingest and prepare, we have a data set for training, as I mentioned to you, and a data set for test. And these ones are going to be the output of this pipeline, this component to be specific. So I import a scalar and so on. I get my data raw. This data is just a data set that's already in place. scite2learn is the fetch California housing. In this data set in here, for regression tests, we aim to understand what's the median house value as a target. We have a bunch of variables that are used to understand what's best for that. And with that, I split my training in training test data. I convert that to CSV. So that's why I use pandas. And this is going to be the dataset train.pep. So I'm connecting this data to the output through this. Okay, so dataset train, dataset test. Okay, so I run this thing in here, and I go now to the training component. So I also install some libraries in here, pandas, XGBoost, that's the model that I'm going to be using. It's from XGBoost framework, and also scite2learn. So for train, what I should use the dataset train. So it's input dataset in here, okay, and what's gonna be the output of this step? Of course, it's going to be the model artifact because I trained my model, and with this artifact in here, I'm going to do the predictions, deploy, and test this model if it's going to perform as I expected. So I import XGBoost, I read the dataset train that I place in here. Then from the dataset train, we have X that are my variables that are going to be used to input the model, and the UI. The UI we call here is the target, the response. Like it's going to be the median house value in this example in here. Okay, so data, I'm going to drop the target, of course, for my X, and my UI is going to be just the target. Okay, so I call the XGBoost regression in here. You can see more detail after the presentation of this notebook. I will allow you guys I will share this with you. This fit is gonna train my model, and then from there I can put more metadata. You remember, guys, that I mentioned about metadata from the Vertex AI? So here I'm saying this is the metadata that I want to be stored, like the framework that I use to train this model and the type. Because I mean, when you go to a real world scenario, we're gonna test a lot of models. So it's better for you to track them, and you can track them through the metadata and other ways through the coding here. And then I save my model. I get this XGBoost regression variable in here, and I save this model in the model artifact. As I mentioned, this is the output, and that's it. And then I already run? No, I never. I hadn't. And then I'm going to go to evaluation. Evaluation, I'm also importing some libraries in here. I have to get my test set for the evaluation, okay, and then I'm gonna get as well as input the model that I just trained, and as an output I would use the metrics from this evaluation, and the metrics are from the type metrics. You remember the artifacts that I told you? So we have metrics, we have data set, and we have the model and the visualization. So we are using here in this example the artifacts as parameter from the components, different from this user pipeline here that we're using the primitive types from Python. Okay, so in here, I'll go to evaluation. We are getting our test data, okay, and then we're gonna do the same transformations, forming the XGBoost regression, but now you're loading the model. That's coming here from the input that you just placed in the component, okay. Then you're gonna predict according to the test set that you have in here. And this prediction, this variables that you got, the result of the median house value, I'm going to go to UI pred, this prediction that you had, okay? And then you're going to compare the UI from your test data set with the UI that you got from the predictions. And this is going to give you the error that you got comparing from the predictions that your model did according to your data that you trained and compare with the real median house value, okay? And you can use mean absolute error, mean squared error. There are a lot of metrics that you could use in here. This is a regression problem, so that's why I'm using these metrics in here. And then I can log these metrics, okay? And when I log these metrics, it can be visible for me in the UI. So this is very interesting. And one thing that I put in here that can be easily added as well is to compare. I put deploy work true equals true because you could, deploy your model when you compare this with the previous run and you see, oh, okay, this model is better than the previous one, so that's why I'm going to deploy that. So you could compare with previous runs in here. I'm not doing that, but you could do. I'm just deploying the next model, even if the next is worse than before, okay? But let's run this component in here. Okay, so deployment. The deployment will receive an input, a model, okay? The project string and the region is a string as well. So I'm here, I can put some logins. So for instance, I could have added this in the previous steps, okay? So here it will be easier for me to understand when I see the pipeline, the interface, what is happening inside the component, okay? Then I will upload this model in the UI, the AI platform, that will be visible in the Vertex AI, okay? So let's do that, and pipeline. So pipeline is the same as we saw in the demo one, okay? So we have a lot of tasks. The ingest and prepare task is the ingest and prepare component, okay? The train task is a train component that we receive the dataset train that's coming from the data ingest and prepare task. The evaluate task is going to call the evaluate component that receives the output dataset that was a test set in that case for evaluation, and the model artifact, okay, because I'm going to run this prediction inside, pointing to the model that I just trained. And then there's a condition here, and that's very nice for the pipelines from Vertex, because you can give conditions to your components to run or not. So let's say I had a condition before, and the deploy is not true as I hard-coded. You could evaluate this in here. So with this condition, I'm evaluating if the output deploy is true. If it's true, then I can deploy my model here. So it's very nice. When it comes to real world scenarios, we're going to, for sure, deploy just if the metric is better than before. And then we compile and we run. And here is very nice because you can enable or not cache, and then you can retrain from scratch with removing all the data that was present before, and add some labels, okay? When I put sync equals flow, it will not give me the parameters as I saw here, the output, okay? It will not put that in here. And I can go back in the pipelines. And yeah, it's running. So you can see here live the pipeline that we just trained, we just stored from the collaboratory. It's in here. So it's running in ingest and prepare. When I click in here, it's going to be visible for me the parameters. And I forgot to mention to you guys, because the prepare sent a phraser, like this is a demo for the DevFest. So you guys remember that I put a lowercase method, right? So the output was this, lowercase for this phrasing here, and the tokenize received this lowercase expression and tokenize it. So each word will be a token, and then I can start preparing my data for natural language data. This is one of the first steps that you have to do when you deal with text, okay? Coming back here, we have the ingestion prepare is still running. And while it's running, I will come back to the presentation just to take advantage of our time that I don't know if I'm running out of time. But you may be asking yourself, like, should I migrate to Vertex AI? And I will give some insights for you. So much easier to manage machine learning pipelines resources with that. Is a reduction in day-to-day flow management configuration files while offering flexibility for the user to change them if necessary. There is a reduction in costs as you asked, the pay-as-you-go model is like pipeline as a service. You pay per run and consume the resources while you're running. Okay, so it's 3 cents instead of continuous uptime for Kubernetes. And also, using the version of Kubeflow SDK, direct access to storage with storage view. That's very nice. So when you're running your components, you're gonna see that there is a phrase there like multi-file system as fuse. So it creates a way for you to manage your files and artifacts very easy inside Google Cloud. What will be the next step? Okay, you can connect your solution to BigQuery, so work with data sets there. Here are some of the things that you could do, like put BigQuery data into Vertex AI, access BigQuery public data sets, access BigQuery data from Vertex AI Workbench, analyze test prediction data. So let's say if you want to understand how is your model working in production, monitor your model. You could do that easily and export Vertex AI batch prediction results. Also, you could use Spark for distributed computing and data props. So I'm using pandas in here, but if you have a large amount of data, you have to use distributed computing. So Spark helps you with that, and you can easily work in the workbench. So here's a workbench to left, right? This is like a view of that. Maybe it's easier for me to not go there right now because I'm running out of time. But here is a workbench, so it's very similar to the Python notebooks, okay? Take advantage of the feature store. So here you can have like a create feature, you would add your feature ID, value type, description, and then you can search for the feature that you just created and using other models as well, okay? You can create schedule pipeline with Cloud Scheduler and Cloud Functions. These two are products from Google as well. And you can schedule pipelines to run every single day, as I mentioned before, in case of recommendation systems or something like this. Start testing. You have like $300. You can start testing with these free credits, and it would be nice to have you testing there. So let me go back here to see if the pipeline. Oh, okay. So in just prepare, we already have our data here. And you can see here the logs. Okay, you can track that, and you can put that you want the bug mode so that you can track more detailed vision. Okay. The trained model you can also see here. Also, you can see where this artifact is stored in my bucket. Okay, but you can also see in the model registry after it's going to be there. You can evaluate your model. So here is evaluating the metrics with the test set according to what I trained. And then there's a condition here that will be used to understand as I place collaboratory, the else that I added, like if I should deploy or not, I heard it called true, but that part in here in this condition, it would be evaluated if my model is better or not, or depending on the condition that you added. Okay. So going back in here, let me. Do you have any questions there? You can ask that because I'm finished the pipeline here.
My question is, so yeah, so
yeah, definitely. Yeah, all the resources that you have to use in the run, you have to pay as well. So it's a fixed per run, but you have to pay all the resources that you may need. So maybe you are gonna need a huge resource, and then you're gonna have to pay that. It depends on the domain that you are dealing. I mean, if you're using deep learning, maybe you're gonna use huge computational interfaces and so it's not. But I mean, I can present my bidding. I mean, is less than. I really have a low pricing, a low bidding here for me. It's okay, you know. It's very, 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 very low because I'm not running a huge model in here. It's actually post regression. So it's not that, how can I say, no, it's not using that to computational power, you know, that I use with learning. But I mean, it's less than $1 running like, I run it a lot of times and it's still very, very nice price. Okay.
It's more like a hobby.
Yeah, but it's still it wouldn't be like a huge. Suppose that you connect with BigQuery with real data, okay? It wouldn't be huge, okay? But you just have to think about how much you are restoring in BigQuery. This is there. It's easy for you to track, and then it's just to connect with pipeline. But maybe you're gonna have a difference in terms of the bidding when you go to BigQuery, because depends on the time of the large amount of data that you have, you know. So, but I cannot say like, oh, you're gonna spend $10 with your solution, because it depends on the time, the size of your data. But here we already evaluated. Okay, so let's see. Let me.
So did you find I see the node info there on the right side, right?
Node, I'm not saying. Node info. No, it's already there. I don't specify that. It's just the parameters that are being used. It's from the interface. Okay. This comes together with the platform. So I mean, I guess we can finish there. Finish here. I can share with you the notebooks. Okay. And I hope you guys. Oh, okay. We finished. So let me go back just to share with you. So it succeeded. Here you can see what I wanted. So this is a data set that I mentioned. This is my bucket already. Okay. So it has data set train, data set test. You can also see the artifacts expanded. Another artifact that's coming from the train step. The evaluate here. We have the metrics. So you guys remember I logged some metrics that I was using, right? So they're gonna be here for me. It's easier for me, but I also can track for the YAML files and so on. And this is the condition. The condition that I mentioned with you, to you, it's in here. And this is calling the deploy, because I mentioned that's let me true, but this condition would check depending on what you place. Okay? So let me go back to the presentation right now. My name is Mikaeri. I'm from São Paulo, Brazil. I'm working as a data product manager at CNT. I'm doing my master's in computer science. I'm a Google developer expert in machine learning. I'm a content creator at Explica.me. Explica.me is an Instagram account and a YouTube channel where I try to make more simple the topics about data science and machine learning. And I'm a founder of Tesseract. Tesseract is a school where I try to teach things about data science as I wanted to be as I wanted to have learned before. Okay. Boston is the company that I'm working right now is data product manager. We support the digital transformation for more than 100 clients, large enterprises, and it's very nice work there because I have this real world scenario very close to me, and I can implement MLOps using the academic background that I have and putting that in the industry. Okay. So these are the references. I can share with you later this presentation as well as the notebook, and I hope you guys like it. Thank you for having me.
Thank you so much. We have our next talk shortly. We're just going to do a little tech setup and get ready, but we'll be starting about 5. We'll let people take their seats and quiet down a little bit. Let me close the door.
So if you're gonna walk around, just like stay behind here.
I'll just stay here.
You go behind this thing?
Yeah, I'll just stay here.
Okay. Thank you all for sticking around. Laptop, Imre, Nagi is here. Going to talk about, actually one of my favorite things is Cloud Workstations. So this is going to be Kubernetes remote development with Cloud Workstations and Skaffold in action. Take it.
Thank you, Lucas. So, good afternoon, everyone. Who's sleepy here? No? Good. So, yeah, I hope for the next probably 45 minutes, we're going to discuss about things. So, if you have any questions, feel free to let me know. So, I'm Imre. I'm going to introduce myself. Today we're going to talk about Kubernetes remote development. There are two technologies that actually coming from Google. The first one is Workstations. It's actually recently announced in Google Cloud Next last year. And also Skaffold. Skaffold is an open source project that Google has created probably several years ago to help developers to work on Kubernetes. So yeah, I'm actually GDE. I'm actually software engineer from a company in Indonesia. So I recently moved to Baltimore, and I fly all the way down from Baltimore to Boston for today's event. And I'm working as in a company named GoPay. So it's a payment company in Indonesia. And I'm actually working on developer experience team in cloud infrastructure engineering. So that's why all of my work are related to how to improve developer productivity. So before we start, anyone familiar with Docker and Kubernetes? Okay, most of you. How many of you already running Kubernetes in production? Okay, quite a lot. So this is how we do typical development in Kubernetes, right? Typically, we have our computer, which is called local development. And then what we do typically is that we implementing features, and then we run automatic tests, and then we build the executable so that we can test it locally. If you're building something like web server or API, you're going to run it in your local, give some input, and then expect some output out of the web server. And then when you are done with one feature, you develop another feature, and then eventually you're going to push that to Git repository. And then when the code is being pushed, the CI/CD pipeline will start kicking in. And then it run automated tests, build the local image, and eventually that image will be deployed to Kubernetes. So that's how we typically do the development. And there are several common development challenges if you're using this approach. I'm going to try to separate it into three different categories. The first one is about development environment setup. And imagine that you are running your application in Kubernetes. Typically, if people start using Kubernetes, they already have needs to deploy their microservice application. So if you are using monolith, you don't really need Kubernetes actually. And that means there are so many applications that you have to develop. And when somebody comes in as a new joiner, you typically provide them with some sort of documentation for their onboarding so that they can start setting up their computer, and also that's where he or she is able to run the application locally. And after that, after probably 1 or 3 weeks, they start getting into the code and start making real contribution to the features. But the problem is it takes time. You need 3 weeks or 2 weeks until 3 weeks so that people can start pushing their first commit to the Git. And then I think we can be better than that. The second problem is about cost of providing high-end machine, because sometimes when you run so many microservice apps in your computer, you probably need more powerful machine. So that's why company end up spending more money so that the developer can be productive by providing them like $3,000 or $4,000 machine. And then it's not cost efficient, and if the engineers leave before 1 year, I think the ROI is just very low. And then even if you already have the high-end machine, right? it's still just one computer. You cannot run your application in a distributed manner. So what you have to do is that you're going to have to deploy it to Kubernetes. But there is also a problem in that. Imagine that when you're pushing the code, you're going to have to run the CI/CD pipeline, and CI/CD pipeline takes time. If your application is simple, it probably takes less than 10 minutes or 15 minutes. But if it's complex, I contributed once to Envoy project, and then just to build the application, it requires more than 20 minutes, and it's not productive at all. And we don't want to waste our developer time in order to run the CI/CD. So that means that we also get feedback slow, very slow. And if you talk about productivity as well, right? Imagine like you're working in a company, you have your computer, but your database that you need to use is resided in private network in the cloud. And in order to connect to that machine, you have to provide the developer with some sort of VPN so that they can connect securely. And there are a lot of things to be managed in that case. And it's not productive because you have to spend more time to do maintenance, operation, and that kind of thing instead of building features. And the last thing is a bit anecdotal. So it's related to security. What if your computer gets stolen? What if your code, all of the company source repository are in your local machine, and somebody get access to that, and then you basically have a code breach. And then we don't want to have this kind of situation. So that's why Google recently announced Cloud Workstation. So if any of you already do development on the cloud, so the experience is pretty much the same. So what Cloud Workstation is, that it's just a VM in the Google Cloud. Workspace? I think some kind of thing, yeah, pretty much. Okay, I forget. So Cloud Workstation is actually a tools or a software that you can use in order to create an on-demand and consistent environment. So imagine that you have 10 developers. How to ensure that all of the 10 developers get consistent environment for development? So that's where you can introduce the Cloud Workstation. And because most of us developers are familiar with IDE like VS Code, in VS Code you typically have extensions. You can install Go extensions or probably Rust and many things. The Workstation also comes with that. So you can install Go extension when you already create the Workstation, and then you can do all things that you typically do in VS Code. And then if you want to test the application, you can also directly test it with dependencies in other VPC, because now your machine is actually on the cloud. So what you need to do is just connect your VPC with the VPC where the resources like database or third-party API are residing. So yeah, the next thing is about security. There are several built-in security like Cloud IAM that you can utilize. The browser that you're seeing here is already HTTPS, so it's more secure. But the things that I like from the Workstation is the customized development environment. What does it mean? So when you create a Workstation, you have to specify a configuration. The configuration will tell Cloud Workstation about how the VM should be created. But the most important thing is that you provide it as a Docker image. So you give them the Docker image, and then it will create machine based on the Docker image. Because we all of us probably have been using Docker, right? So, and then it will be easier if we can do it that way. So Workstation is actually part of Software Delivery Shield. But if you're talking about this thing, the Delivery Shield, it consists of several things like DevOps, supply, CI/CD, and runtime. But Workstation is only part of the development side. And then this is the solution coming from Cloud Delivery Shield. And if you see here, this is where we start the development. And then we start a CI/CD pipeline, and we put it in the artifact registry. Eventually, the application will be deployed either to Kubernetes, Cloud Run, or any other type of platform. This is how you're going to configure Workstation. I'm going to demonstrate it to you later. But there are several terms that we need to know. The first one is about Workstation cluster. Cluster is just a logical group about your nodes. So the cluster will tell you that the VPC, the Workstation that we'll be using, something like whether you have private VPC or which subnet that is, and so on and so forth. And then once you have that cluster, you can create one or more configurations. So if you see here in the first configurations, you can specify the IDE that you want to provide for developer. In this case, it is IntelliJ. Okay, and you can also define the machine spec for that configuration. Let's say, because you know that Java takes so much memory, right? You probably want to, I see somebody. We know that Java takes so much memory, so we will provide them with high memory instance. But if you're using Go, probably you don't need that high memory. So you can provide with a different configuration that use probably Golang and probably lower CPU spec and memory spec. And then for each configuration, you can also tell the workstation who can create workstation by using that configuration. So you can define, let's say you have group of Java developer, Go developer, and so on. You can assign permission directly to those groups. And then once you have configuration, you can just create a workstation by using that configuration, and it will instantly create you a new machine that you can directly use. This is a bit about architecture. If you see here, the security, when the security that we can utilize when we are using workstation is more on the IAM side. So you can provide roles to the user, so they can create workstation, they can remove it, they can manage it, and so on, or probably provide them with Docker-based image that you want to use. And eventually, it will be residing in the VPC network of Google. So it's just a VPC. So if you have resource in other VPC, you can just use VPC peering or other type of connectivity methods. And then your workstation, because you provide them as a Docker image, right? When you create the configuration, there will be a new VM created with that Docker image. And you can also have a persistent disk, so that when the VM is stopped, probably at night, because you're not using it for development, you can keep the disk and then use it later tomorrow. So let me go to demo. I think, yeah, this is the UI, so Cloud Workstation. So this is the cluster that I mentioned earlier. So I already have one cluster. This is showing us that where this cluster is located, US Central, what the network that is using, subnet, and so on. And that's it. That's it for the cluster. And when you already have cluster, you can create configuration. Let me see what we can specify on new configuration. You specify the name, and then where this config can be used, which cluster. And then you can also define several things about how to save the cost. So if you want to have lower cost, probably the startup of the machine will take a bit longer. You can also define the pool size. And after that, wait, let me just one. And after that, you can define which machine that you can use. There are several options. You can choose whether you want to have higher memory or low memory. Just FYI, if you use the smallest type instance now, the cost per month for a developer, assuming that you work 8 hours a day, it will be around $40 per month for one developer.
So you have to book it for the whole month, or is it per hour?
Per hour. But if you're using consistently 8 hours a day, for let's say 20 days in a month, right? It will cost you around $14 bucks.
One thing about that, we're currently in the preview period.
That's right.
So I think currently the only costs you're incurring are the cost of the VM.
That's right.
Storage. But there will be like a control plane cost that will eventually come when they make this product GA. And so I don't think we know really.
Yeah, I think the price is not there yet.
Yeah,
So
they haven't announced what the control plane cost is. So there is a persistent monthly cost to have a cluster, and then there's a per second cost for using a workstation.
Exactly.
We don't quite know what.
I never use GitHub Code Workspace actually.
This is a full container. You can run whatever you want.
That's right.
It looks like the whole IDE and around.
Okay.
I would say you run whatever you want to run.
GitHub Code Spaces might be more analogous to the Cloud Shell, which is like it's just a shell in a browser. You don't have any real control over it. This is like Cloud Shell and Skaffold, so you can control which region, which VM, exactly what runs in the operating system. It is that. It's exactly that.
Exactly.
And this, it's running from Linux, right?
Yeah, it actually depends on the image that you're using, but I believe they have support for Linux, but I'm not sure about Windows. But I think they have support for Windows. I need to check the documentation. Yes, please. I'm sorry, what's the question? You didn't get it.
Google or the you don't have as much. Oh, I'm not familiar.
Good part.
Oh, okay. It's worth looking at.
Yeah.
I think part of what Google,
obviously, it puts up again. And we do all our training on this part. You don't have to have anything everything automatically for you. And does the job. I can't use any scenario. I use just go one thing that's mentioned is BPC, which is running your service control, your security, your development board to cut off the problem. You want all my development drawings and you're having to protect the environment. Protect the board. Okay, that's it.
Yeah, I think it's really all the customization that you have to do that makes it different from these other solutions. You should just both of them. Inside Google BPC.
Okay, so let me continue the demo first. Yeah, this is the machine tab. You can probably define several config for cost saving as well. And then there are several advanced configuration. You can also do encryption if you have some sort of requirement for your system, because probably some highly regulated company has that kind of thing. So you're gonna you can specify encryption, and also you can provide your custom encryption key as well. And then after we complete this, I think this is something that I like. Okay, I'll go to that. So yeah, if you have a local file, what you're gonna do? Because we want to create something like a consistent environment for developers, right? So typically, what will be inside the workstation will be something that will be needed by all of the developers. So let's say that if you have a file that you want to put into workstation and it applies for all developers, you probably can define it in your Docker file. So that's how you're gonna do it. So you put it inside the Docker file, or you can create a script that will pull that file.
I have a program.
Okay.
So I can have a program on the workstation. Now I have a sample data set which I want to keep Excel or
Oh, yes. Is that applies for all of the developers?
So that is a unique text with my code.
Okay, let me finish the demo, and then you will be able to see what interface that you might have later. Okay? Probably it will answer your question. So you can define custom container. In my case, I already create a custom container, a custom Docker image, which install Helm into that, so that we can do deployment later with it. But if you just use base editor for code RSS, it doesn't have Helm installed on that, so you can configure any softwares that you need for your if you want to install Info, you can also do that by providing a Docker image that has Info installed. And this is this configuration. Yeah. Which one? This one? No. Okay, so this is something that I would like to show actually. During my time as a developer, this is something that really bothers me because I have to find the value for all environment that I need. So if you configure the environment variables that you need for all of your developer, you can just configure it here, and then once they run the workstation, they will be able to use that directly. So this is something that I find really useful in our current workflow. And once you have this configuration, right, you can just create a new workstation by giving the configuration itself. And then because I already have one here, I'm just going to launch it directly. So what you will see here is just a VS Code, but it is in the browser. And I already have GitHub connected into this, so it's just the matter of GitHub authentication. So you can pull the code from GitHub, or probably in other repositories, you can also do some sort of authentication for SSH, something like that. And then you can have extensions like what I mentioned earlier. You can install Go extension and any type of extension that you typically use locally. And then once you have this, once you have your code, let me open the code. It's pretty much the things that you get. This is the code that I already pulled, and then I also have terminal. So the question is, if I have file that I want to upload to this machine, what should I do? I just probably can pull it by using gcloud command and then put it inside the VM, if it's just specific for my case. But if the test data that you mentioned earlier is valid for all developer probably need it, you probably will create a script so that the data will be pulled when the workstation is created. So that's kind of automation that you can do. This is about workstation. This is pretty much, I'll go back to the slide. We'll continue later with Skaffold. But even after we use workstation, right, there are several problems that is not solved yet. Even when you're using workstation, you don't have similar environment like what you have in production. You are not running your application in Kubernetes yet because you just have one VM and still it's a single machine. And then it's still hard to get feedback about changes, and CI/CD still takes time because when you do development from from workstation, you're going to have to push and then wait until CI/CD is completed. And then what we can do, how we can improve this. So instead of doing testing and debugging from local development, why don't we shift the way of work into deploying directly to Kubernetes from our local? We can skip deployment by using CI/CD until we are ready, that our code is actually tested and it works as expected. So when we developing features and we run automated tests, and then we probably want to run application directly on workstation. Yeah, the cycle is pretty much similar, but the differences is just this part, run and debug application in Kubernetes. How to do it in naive way? You can create a script, deploy local SH, you build the Docker image, Docker build, you push it to some sort of registry like GCR or probably Docker Hub. And then once you're done with it, you probably want to deploy your application. You run kubectl apply, -f, and the manifest YAML. And then once you're done, the application is deployed, you want to test it from local. So you do kubectl port forward, and then you have a port in your local so that you can just directly test it. But what if you want to check the log? You run kubectl logs, and then the log will be streamed into your local computer. This is the naive approach. But there are a lot of things that you have to do every time you do it. And there are problems remain for this approach. There are a lot of ways and end up in your probably in cloud or probably in your machine and so on. Let's take example like Docker build. When you do code modification, Docker will create a new layer of image, right? And then that image will end up consuming your resource, your disk. And that's something that we don't want. If you're using something like GCR, probably the cost of GCR will keep increasing if you're not maintaining that, if you're not doing a frequent cleanup. And if you do development directly to Kubernetes, when you deploy your application, you probably forget to clean it up. It's okay if your developer is just 1 or 2 people, but what if your developer is 100? What if the 100 developers forget to remove that unused deployment? What happened? You end up having high costs because no one wants to really remove that because they are not sure whether it's important or not. So that's something that we want to solve by introducing Skaffold. So Skaffold is actually a tool that help you to optimize source to Kubernetes development. What does it mean? You have Skaffold in your machine, and then when you run Skaffold, Skaffold will do something like file checking to check whether there are any changes or not. And if there are any changes detected, it will run the entire pipeline to deploy your application. Once it is done, it will clean up everything. So you don't need to worry about whether you have some leftover that you forgot to clean up and that kind of thing. And then you have seen the script that I showed earlier. It's about...
One question, is Skaffold a part of Google Cloud or is it some open source?
It's open source, but it's originally coming from Google. So Skaffold is also the technology that is used for Google Cloud deploy. So for the continuous feedback, right? Once you run Skaffold and then the application is deployed, Skaffold will actually port forward the pop into your local machine and then also stream the log directly. So you don't need to run more comments in order to check the log, doing call from your local and that kind of thing. So the interesting part is about enables live debugging. So some of you probably have experience configuring live debugging for container running in Kubernetes or something like that. And Skaffold also can help you do that if you have proper configuration. But I'm not going to demonstrate it today because I think there are a lot of things in documentation. I think it's better for you to check that out. And then if we are working with Skaffold, there will be manifest YAML that we need to prepare. We're going to go into that later. But Skaffold is actually a lightweight client just running on the client side. So there is nothing that you have to install in your Kubernetes cluster. It's just on your machine. In our case, it's in Workstation node that we created. It has support for multiple build and deployment tools like Git, Buildpack, Docker, Helm, Customize, and so on. And the most important thing is that it has IDE integration as an extension for VS Code and IntelliJ. So the name is Cloud Code. So how does it work? Like I mentioned, it has file synchronizer that will detect changes. But if you don't want to have deployment every time you press Command S to save the file, you can also change it to on-demand basis. So once you deploy it, it will build the artifact, run the test against the artifact, tag it automatically for you. And then because during the development, you specify what manifest that you want to use for deployment, right? It will also use that manifest, render it, and then deploy it to the Kubernetes cluster. And once it is deployed, it will tell the log forward. And when you are done, it will be cleaned up. So that's how we can remove a leftover from the clusters and probably in our computer. Because if you end up running Docker build every time you test, right, you will consume more disk space on your computer. And when the problem comes, you actually forget. Yeah, please. Yeah.
So you may not find the mix, but when I started, especially when I focus on the numbers, I don't know exactly all Skaffold was and use it in terms of giving us that. What is clear, you want a so I think what they're saying is a plus element.
Yeah, I think I agree with that. Okay, let me show you demo a bit. So this is the demo. So let's go with the Skaffold YAML first. So I actually have a file that I use for Cloud Run Hackathon, I think last month. So there are a lot of files, but that's not something that I would like to demonstrate. So I have a Skaffold YAML. This is the config file that you're going to use in order to tell Skaffold. Let me go to the file. So you can define several profiles that you want to use. You can use something like development, staging, and production. And then in my case, I just have two profiles. The first one is Helm profile, and the second one is Kubernetes. So what this profile does is actually it uses Helm to deploy the application, and for the Kubernetes, it will use the manifest of Kubernetes, the native Kubernetes manifest to deploy the application. And apart from that, you can also specify how the application will be built, how Docker image will be built, whether you want to use Google Cloud Build or just build it in local. So this is how you're going to use Skaffold. And actually, if you want to run this, you can just use Skaffold dev command. But I think the easier way to do that is by using the Cloud Code extension. So when you are using a base image provided by Google Cloud, Skaffold is already installed on that. So, okay, yeah, so let me go to this a bit. I have a deployment folder where I provide several ways of deploying this application. Because in this profile, I'm using Helm, right? I'm using Helm. I need to provide the chart path. Chart path is here, actually. This is the chart that we're going to use. There is some sort of value, and then there is a templates for deployment. And then if I don't want to use Helm, let's say I want to use Kubernetes manifest directly, I can also do that. Actually, this manifest is generated from the Helm chart, so it's actually the same. But in this case, I'm using native way in order to deploy application. But you can configure that in Skaffold. You can provide whether you want to use Helm, and kubectl manifest and what manifest that you want to deploy, what image that, what chart that you want to use, whether it's in your local or whether it's running on, it's stored in cloud, something like that, remote repository, that kind of thing. You can also define the namespace. So pretty much all of the configuration that you can have in Helm CLI, it is provided here as well. So no, it's not. We're not doing anything with Terraform. We are just deploying the application, so we don't need any Terraforms. Oh, this one you mean? Yeah, this is something different. So
what exactly does it thank you?
Oh yeah, so this Terraform is actually, I use it to deploy the application to Compute Engine. So for this talk, it's not actually relevant. Yeah.
And does it get added by default because you do the
Which one? No. All of the code that I wrote here is just by myself. It's not automatically generated when you're using Skaffold.
Go back to the config file that you're showing.
Yep.
There was a target for Helm, but there was no target for Terraform.
Yeah, that's right. Because we are deploying an application, right? We are not creating infrastructure. Yeah. So
I understand that part, but the generate as a
no, it's totally different. If you want to create VM or any resources in AWS, you can provide Terraform modules, right? But this is not something that I use for Workstation and Skaffold demo. But I have this so that I can deploy the same application to the Compute Engine. So it's actually different talk. But because I just use one repository, so I put all of them on the same repository. So yeah, this is pretty much the config, and actually the rest will be the same. You will have Docker file. Where is it? This is a Docker file, a simple Docker file. But if you want to enable live debugging, you're gonna have to install something like VLC so that you can configure the remote debugging and then tell Skaffold which port to use. And then, but I'm not doing it now. What I'm gonna do now is that I will just go to Cloud Code and then run it directly on Kubernetes. So if you see here, I already have Kubernetes cluster connected, but nothing is installed now in Kubernetes. So when I run this, you will see that Skaffold will be initialized. See here, and then it will run command like Skaffold dev, which is used for development. And then it will start building the container because I already built the image before, so we already found it remotely. And then it starts deploying the application by using Helm. Wait, let me check which profile that I'm using here. Yeah, we're using Helm. So this application is actually deployed. Waterfall Skaffold Kubernetes is ready. And then if we see here in port forward, it's actually port forward the port from the service to your local. So if I test it, localhost 8080, I will start seeing response from the API. But if I want to check what log is coming, I can also go to this log and see that the log is streamed to my terminal as well. So this is Skaffold. But I told you, right, how to get faster feedback if you do development. It doesn't make sense if we have to skip the CI/CD pipeline and then start the pipeline from the beginning just to test whether small changes that we did is actually working or not. So that's where Skaffold is actually coming handy. Let me change a bit. In this case, I have two statements. The first one is for debugging, and this one is for printing the output. I will change both of them. Just add two, or I will add Skaffold demo in Boston. I'll do the same Skaffold demo. So if you see here, when I save it, there will be a process be executed here. So Skaffold will try to rebuild the image by using changes that we recently saved. And then once it is done, once the build process is done, I'm currently using the Google Cloud Build, so we're gonna need to wait. Once it is done, we will try to call again and then see whether the response is changed or not. So at least what you can save from using Skaffold is actually the time. So you can directly deploy to Kubernetes without really have to maintain the complexity of running your bash script. If you have to run probably several scripts or several commands, you don't really have to do that. And once you are done, you don't really need to clean that up. And then let's wait. It's gonna take a while, but I can take questions if you have. Yeah. That's right. Yeah, I kind of get the same feedback. Yeah, thank you. I think I got the same feedback recently. They said that why GCP just released it now, while other provider already did that probably a long time ago. I don't know why they just did it, but I think this is something that will help us working in a big team. So especially because I'm working on developer experience, right? I need to find a way how to help the developer to be productive. And because we already in GCP, so that's why we try to see whether this technology might fit our use cases or not. So we kind of play around with it and try to think what needs to be added on top of this. Yeah. That's right. Yeah. I think the way we see it as a developer experience teams compared to developer is a bit different, right? So from our point of view, we probably need to help them to have less context about the technology that we are using, whether it's Kubernetes, Docker, because in our company, we don't really expose the developer how to build the image. We just need to provide us with this, and then we build everything and we deploy everything. That's how we work. But sometimes the developer wants to know more about it. We also want to tell them this is how we do it. But most of them probably doesn't really care about what we do. What they care the most is just how they can ship the feature faster. So that's why we are exploring many things, and this is something that we are trying to see. I believe so, but I haven't installed it yet because it's
there isn't a Copilot plugin for Code OSS, but if you use any of the commercial ones like the PyCharm or Golang, they have GitHub Copilot for that.
I see.
So using the native open source in-browser editor, no Copilot, and any of the supported proprietary ones.
I see.
The other thing would be, maybe I hope I didn't get it wrong. When you had the option there, right? You had PyCharm and you had Subprototype. You don't have to pay extra for that, right?
Correct.
So that's included in the
So what is in that container image is a daemon that runs on the Python server. You connect to that, still need a paper Python. So I have Python professional because I'm a GDE, and I pay nothing to Google for that image, but my paid license of PyCharm is what I use to connect to the server.
So if I don't have a PyCharm license, I can't.
You won't want to use the PyCharm image. You'll use the Code OSS image with the free browser editor. And you could connect to VS Code. So one thing I don't know if you mentioned is like those workstations, they are SSH accessible. You can make it out with a, what is it called? Agent or something.
SSH agent.
Be able to SSH into it, and then you can use whatever, anything you want. So I use VS Code to run it on my local machine, connecting over SSH to the workstation.
Yeah, it's pretty much the same if you have a VM running and then you directly do remote development, remote code, if I'm not mistaken, the term for the VS Code. But yeah, so let's try call again. So looks like if you see some big changes. Previously we have not checked done, and now have checked done with empty white space. Why? It's because probably I pressed Control S before I start before I so that's why it directly deployed these changes. But I think what Oh, no. It's a C here. It's a C. It's here now. So the changes is actually already reflected after you run the scaffold again, after the scaffold run. That's right.
Can I do that same thing?
Yeah, absolutely. You can do the similar thing, but I didn't have demonstration for that because in Go, right, because it's a compile language, it's kind of different with other language. You gonna have to set up something like the DLV server so that tools like Skaffold know how to jump into breakpoint and stop it at a certain breakpoint, that kind of thing. But you have to install at least DLV because this is Go app, right? For Go, you have something like DLV that you can use to run remote debugging, and then you add it to your Docker file, and then run it, as a server on your application, and then it will somehow like forwarding the request to the application. So that's pretty much. So actually, Google Cloud also mentioned about it. This is how you're gonna specify the command. In this case, let me go here. I'm using entry point for just directly triggering my app. But if you want to use DLV for enabling remote debugging, you're gonna have to change the Docker file a bit. So you're gonna have to provide a Docker file for development, and after that, you specify the port here, probably 1, 2, 3, 4, and then you tell Skaffold which port that you're gonna use for remote debugging. I'm sorry. Enable for which one? The Skaffold? Oh, no. If you run Skaffold back, once you stop the command, let me show you. Yeah, I haven't demonstrated yet. So let me stop this. This is a stop button that will stop the Skaffold. And then everything will be stopped. And then if I check the port, sorry. Oh yeah, how Skaffold know when it should do the thing. So the answer is when we stop the Skaffold CLI or cloud code plugin. So I just did it by pressing a stop button right here before, and then once I stop it, everything will be cleaned up, including Docker images that I have locally if I use local build mechanism. But now, because I'm using Google Cloud Build, there's no way that you can do for now because it's actually open issue in Skaffold. If you use Google Cloud Ministry to store image from Skaffold, you cannot automatically delete that. So it's a limitation. So you're going to have to probably provide with some sort of cron job to clean that up. Because I think if you want to use this for development, you're going to have to provide something like dedicated project, right? A dedicated project or cluster just for development. And then if you know which resources need to be cleaned up, you can just automatically execute it. I think that's it. Let me check. Yeah, I think that's it for the Skaffold. After we did Skaffold demo, all of the problem here should be solved, hopefully. Yeah.
What is the best way to reach out if you have any
I'm in Twitter, Imre Nagi. I think that's the best way. I'm active. I actively tweet in Twitter, but I'm sorry if sometimes it's not real fun. But yeah. Is there any questions? Otherwise, I think, yeah.
That rollback will also be possible, right? Like when you are deploying and you want to roll back to the previous code and
You mean, will it be possible to use Kubernetes rollback? Yeah, it is possible actually. But you're gonna have, you will have to automatically run the command in your VM. kubectl, what's the rollback, something.
what about the name? Like if I have to roll to different tasks?
Actually, yeah, that's a good question. I think in Skaffold, I'm not really sure how it works internally, but I need to check that out. The question is, if I want to roll back, which image that will be used for the rollback? Because in Skaffold, the limitation now, I'm not sure whether it's limitation or not. But the thing that I observed that if you do deployment, it will use the same tag for the deployment. Yeah. Yeah, that's one way. But I think if you do rollback, right? If you do rollback with Helm, if the image tag will be the same, it will just point to the same code. Because, yeah, if the base image is different, yes. But if the image version is the same, there's no way to go back because the new image tag is already there. Yeah, it's already replaced. But I think because we are just doing remote development, right? So we can just directly change the code and probably roll back to previous commit and then redeploy. That's we typically do it. Yeah. In general, even I run Skaffold locally. But the things that I want to demonstrate is that you don't need your local computer anymore in order to do remote development for Kubernetes because you already have a workstation in the cloud and then Skaffold on the machine. So you just directly run Skaffold. Yeah. Yeah. What I need is just browser. I don't even need my Mac anymore. I can just use my iPad if I want, something like that. Just, for my case, I think it's less than 3 minutes actually. But you mean for the rollout, right? Yeah, I mean, because I think the things that takes time is actually the image build.
By default, when you save, it rebuilds.
Yeah.
So it'll be instantaneous. If you want, you can have it wait until you rebuild. But then the time, the length that it takes to rebuild just depends on what you're doing and how long it takes.
If I code so wait, it's still change with the local file system.
What do you mean by wait? Tell it to wait.
Well, let's say I don't want to do that.
Okay, so
it's saving on the server, not saving a local copy that is later going to send to the server instantaneously.
The process that would have to pick up on that thing will probably go.
Yeah, the process of saving on the workstation, get the file on the system contained, then we'll be ready.
Yeah.
So in that case, you should really rerun that and how about it?
I think all you're saying it's 3 minutes.
Yeah, I think 3 minutes. Sorry, 3 minutes for just building the image. But if you, what I mentioned earlier, if you don't want to redeploy every time you save, you can just disable this. So Skaffold will stop watching your changes. But what you have to do is just trigger it directly from the cloud code. So you have to press this button every time you want to do redeployment. Do we still have time? Okay. I don't know. I don't have any feature request that I want, but I think what I need the most is about how something like documentation that can help me to understand how I should configure the base image for this kind of thing. So it's more like tell us what is the best way to do so, because actually when I prepare a custom image for this, I take so much time to understand how it will build the image, how it will get created. When we create the configuration, you can specify the service account. The question now is where this service account will be used, whether it's going to be used when we create the VM or when we execute the preparation for that VM itself. That's something that I found confusing, so I think I don't need any other feature right now, but I like to have more clarity in terms of that. Because now if you see here, I can also connect my G Cloud account. The question now, why do we need the service account? That's something that's not clear to me. That's right.
So you have like an intermediate people today right now make changes to it.
No, it will clean up once the scaffold is stopped. So if you run it 10 times, let's say if you did add modification after you start the scaffold, it will keep the image there, but when you stop it, everything will get cleaned up.
Okay. Is there a way to force it to clean up?
I'm not sure. I'm not sure. Yeah.
Scaffold, if you go to that file, I'm just curious, like, it's kind of
It's actually using Kubernetes CRD format.
right, so, but say that if it's a good page, say that like I want to deploy these kinds of resources and on the web service and all this kind of stuff. Like, is the scaffold handle referencing that somehow?
Nope. Use reference that in your manifest YAML. So you mean something like CPU or memory, right? Yeah. So you specify it here because it's specific for your app. So Scaffold doesn't really have to know what is the resource required to deploy an application. It just need to know which manifest to be deployed.
Yeah, that's exactly my question. Can that manifest can that point to a different?
Good question. I'm not sure. Yeah. Any more questions? Thank you so much. Thank you.
Yeah, let me put up a little thing on the screen.
Oops.